चेक चेक चेक। हेलो चेक। चेक चेक चेक। हेलो चेक। चेक चेक चेक।
check. Hello, hello, check.
Om Amriteshwariye Namaha. A very pleasant morning to all distinguished dignitaries, respected faculty members, invited speakers, researchers, students, and delegates joining us from across the globe. It gives us immense pleasure to welcome you all to the IEEE International Conference on Robotics and Mechatronics, ICRM 2025, organized by HUT Labs, the Amrita Center for Advanced Robotics, and the Department of Electronics and Communication Engineering, Amrita Vishwa Vidyapeetham, Amritapuri campus.
This conference provides an interdisciplinary platform for researchers, academicians, and industry experts to present their innovations and to discuss advances in robotics, mechatronics, and humanitarian technologies. Before we begin, let us all invoke the divine blessings of Amma, Sri Mata Amritanandamayi Devi, Chancellor of Amrita Vishwa Vidyapeetham, whose vision and compassion continue to inspire and guide us in all our pursuits. Let us all kindly rise up for prayer.
गुरुभ्यो नमः हरिः ओम् ध्यायामो धवलावगुण्डनवती तेजोमयी नष्टिकी स्निग्धापाङ्गविलोकिनी भगवती मन्दस्मितश्रीमुखी वात्सल्यामृतवर्षिणीं सुमधुरं सङ्कीर्तनालापिनी श्यामाङ्गी मधुसिक्तसूक्तिम् अमृतानन्दात्मिका ईश्वरी ॐ अमृतेश्वर्यै नमः ॐ अमृतेश्वर्यै नमः ॐ अमृतेश्वर्यै नमः
To begin this auspicious occasion, we would like to invite our esteemed dignitaries seated in the front row to kindly come up to the stage and grace the dais.
In Indian tradition, lighting the lamp signifies the dispelling of darkness and the ushering in of wisdom and prosperity. It is a sacred ritual that marks the beginning of auspicious events. May I request all dignitaries on the stage to kindly come forward for the ceremonial lighting of the lamp. Everyone, please rise up for the lighting of lamp.
ॐ अमृतेश्वर्यै नमः 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 ॐ अमृतेश्वर्यै नमः
As the lamp is lit, let it symbolize the enlightenment that this conference aims to bring to all its participants.
Thank you, esteemed guest, for gracing this moment with your presence. With the lamp lit and the stage set, let the event begin on a radiant note. To extend a warm greeting to all the delegates and dignitaries present here, may I now invite General Chair of ICRM, Professor Dr. Rajesh Kannan, Director, Humanitarian Technologies Laboratory, to deliver the welcome address.
Om Amriteshware Namaha. A very warm good morning and a very warm welcome to everyone. On behalf of Amrita Vishwa Vidyapeetham, Amritapuri campus, it gives me an immense pleasure to welcome you all to the first ever IEEE International Conference on Robotics and Mechatronics, ICRM 2025 at Amritapuri campus. We are deeply honored to host this landmark event on our beautiful campus situated amidst the serene backwaters and the inspiring presence of our Chancellor, Sadhguru Sri Mata Amritanandamayi Devi, our beloved Amma. The preparation for this conference started more than 1.5 years ago. Being first time, it took quite some time to get the technical co-sponsorship from the IEEE, without which we cannot publish the presented papers in IEEE Explorer. Also, IEEE has a mandate that there should be a gap of at least 9 months to 12 months from the date of announcement of the call for papers for any conference. With the technical co-sponsorship from IEEE confirmed, we can publish all the presented papers in the IEEE Explorer database and also get Scopus indexed. We received 467 papers in total, and after peer review, accepted 182 papers for presentation. Out of 182 papers, 120 papers got registered for taking part in the conference, and the delegates came for presenting their papers. Apart from paper presentation, we have 24 keynote talks spread across the 2 days of the conference. A total of 26 speakers, including the chief guest and the guest of honor, are going to grace this significant occasion and share their experience and expertise. We are also hosting workshops, robo competition, poster presentation competition as part of this conference. 179 registered for the workshop and 60 for the poster presentation and 19 for the robo competition. Apart from these events, we have also arranged for 2 expos, one on robotics and another on smart vehicles. There are 17 car companies with 23 vehicles taking part in the Smart Vehicle Expo. A total of 12 companies and research centers with a total of 30 exhibits are taking part in the Robo Expo. We are also going to distribute 2 artificial intelligence based coconut de-husking robo or machine, which were built at Hut Labs in collaboration with the Mariko Kalpavriksha Foundation and funded by IEEE EPICS America to the beneficiaries of this project. It is indeed a proud moment for us to bring together an eminent gathering of distinguished guests, keynote speakers, delegates, researchers, academicians, industry experts, and students from around the world. Your presence here marks a celebration of innovation, collaboration, and the spirit of scientific inquiry. The field of robotics and mechatronics are transforming the way we live, learn, and work, driving progress across the industries, healthcare, education, and also sustainable development. This conference provides an ideal platform to exchange groundbreaking ideas, present pioneering research, and foster global partnership that will shape the future of intelligent systems and human-centered technology. We extend our heartfelt gratitude to the IEEE, our technical partners, sponsors, and organizing committee members for their invaluable support in making this event a reality. Over the next 2 days, we are looking forward to engaging keynote sessions, insightful paper presentations, and vibration discussions that will spark innovation and inspire new collaborations. Now, let me get to my duty of welcoming the delegates, the chief guests, guest of honor, and all others present today. So the chief guest for this occasion, Sri Kannan Tajpur Sampath, Managing Director, VIT Semicon Spark Private Limited, Ratnagiri, Maharashtra. I welcome you, sir, on this occasion. The guest of honor, Sri Ramanathan Srinivasan, Managing Director, Automotive Test Systems, Delhi. Welcome, sir. Benevolent address by Brahmachari Achyutamrita Chaitanya, Principal, School of Spiritual and Cultural Studies. Welcome you, Swami. Then I welcome our beloved Associate Dean, Dr. S.N. Jodi. Welcome, Madam. Our Chairperson, Department of ECE, Dr. Ramya. And I welcome all the keynote speakers assembled here today, the beneficiaries of the IEEE EPICS project, the faculty members, the researchers, the faculty members of our campus and other campuses, the delegates who have come for the paper presentation, the student community from multiple campuses, including Etimadai, Chennai, Nagarkoil, and also our Amritapuri campus, and all others, the HODs, the researchers from other centers, and the various departments, like people from various departments. I welcome you all on this grand occasion. So with this, I conclude my welcome speech and look forward to the hearing from the speakers. Thank you very much. Om Amriteshwari Namaha.
Thank you, Professor Dr. Rajesh Kannan, for that wonderful and heartfelt welcome. It is a privilege to have our chief guest, Mr. Kannan Tajpur Sampath, Managing Director, VIT Semicon Spark Private Limited, Ratnagiri, Maharashtra, with us for the inaugural address. I request Dr. Gayatri N., Vice Chair, Department of Electronics and Communication Engineering, to introduce the chief guest.
Om Namah Shivaya. It is indeed my honor to introduce the chief guest for today. Mr. Kannan Tajpur Sampath is the Director of VIT Semicon Spark Private Limited, the Managing Director of VITPark Private Limited, and the Chief Executive Officer of Bio WMS Private Limited. A visionary industrial leader, he is driving the development of a semiconductor and electronics manufacturing hub in Ratnagiri, Maharashtra, focusing on silicon ingot manufacturing, semiconductor fabrication, and ATMP, assembly, testing, marking, and packaging. Through BioWMS Private Limited, he promotes sustainable waste-to-energy solutions such as biogas and bio-CNG. With extensive experience spanning infrastructure, manufacturing, renewable energy, and industrial consultancy, Mr. Kannan has held senior leadership and consultancy roles across prominent organizations. As director at Jagannath Dairy Products Private Limited, he led the design and technical planning of a 500,000 liter per day milk processing facility. As director at High Tech Infrastructure Property Development Private Limited, he provided industrial development consultancy for major national projects, including airports, thermal power plants, sugar mills, medical colleges, and metro rail systems. Serving as a consultant for Grasam Industries Limited, he managed limestone quarry operations and pioneered a pollution-free fly ash system for the Mettur thermal power plant under Tamil Nadu Electricity Board. He also contributed as a consultant and liaison officer at High Tech Carbon, Aditya Birla Group, overseeing civil, mechanical, and process equipment commissioning, including water treatment, demineralized water, and nitrogen utilities. As a project consultant with Jurong Engineering Limited, Singapore, Toshiba, and SPIC JEL, he played a key role in petrochemical and power plant execution and commissioning. He also served as an engineer at Manali Petrochemical Limited, managing milk of lime plant operations, limestone procurement, and regulatory approvals for mining and mineral projects. Mr. Kannan Tajpur Sampath continues to champion sustainable industrial growth by integrating technology, efficiency, and environmental responsibility across sectors. It is indeed our honor to invite you to the dais.
Very good morning, everyone. First of all, thank you for Mata Amritanandamai Amma to brought me here in the stage to Amritapuri. Once I met Amma first time, she said we are having a project of this semiconductor in India. Amma said her vision was 25 years before, 25, 30 years before, our country needs hardware manufacturing, semiconductor, these kind of manufacturing facilities. She was tried 30 years before. She said, my vision and dream is coming now only to India. So first of all, I have to pray and God blessings of Amma and starting my speech here. I don't want to tell much about the technical things about robotics and other things because many experts are here and then manufacturing people are here. I have to say few lines about the robotics and mechatronics. The semiconductors are the basic brain of this robotics because how the human being can function with a brain and nerve system, similar kind of thing, all the process, stimulation, everything can be happen only with a semiconductor. In India, our Honorable Prime Minister having the very good vision to bring this kind of technology projects and then technology innovations to India. So the first kind of thing in India, our project is that with a integrated semiconductor manufacturing unit. This will make a wafer manufacturing from the wafer to the fabrication of the semiconductor and then another assembly, testing, marking and packaging. Why we are explaining about the semiconductor, there is a robotics cannot function without semiconductor. There is industries related to each other. That semiconductor and then these robotics, mechatronics, electronics is underlying with the semiconductor. Even a CPU, GPU, or whatever the system, sensors, everyone requires a semiconductor. Our government vision is to bring the industries here in India. There are two companies India is coming up now in the fabrication. One is the Tata Projects. The next one is the VAT Semicons. We are going to employ nearly some 33,000 employees. And then we are aligning with Amrita also, Amrita University, to give the Center of Excellence training and other things here. Yeah. Our semiconductors are in India. Now it's in a very beginning stage. We need a more skilled engineers, there is a requirement of 1 million skilled engineers in India is the requirement is there. So there is a lot of opportunities available here in the country now itself. Now also we are in the process of recruiting 500 engineers in our project in the first phase. So similar kind of things, everyone can little bit try to find out semiconductors. So there is a bright future for semiconductor industries in the country. Now India has approved many projects. Only 2 projects are a fabrication. Our project is the only one with integrated with the wafers and inclusive of all items. Other packaging industries also coming up in India. One is the Micron, Keynes Technology, CG Power, and many industries has been approved. Already 6 approvals has done already. So these projects is the key success and in the country's security aspect. The government of India wants to establish these things in a very fast manner. So this is the semiconductors is now we wish to manufacture our own sustainable production here. In our company, we are doing with the semiconductors with the green power also. We are already having this biogas, bio-CNG. And then now we are making with the hybrid power with the solar, BSS, and then this biogas power. Combined together, we are going to use in our semiconductor project. Our project will be we can say proudly, we can say our chips will be the green chips from the power sources from the green energy. So these are the things to inputs, how the green energy is also important, as well as the electronics and semiconductor manufacturing, the robotics, all are the energy is required to drive the robotics, everyone. So the semiconductors will be the brain for the robotics and electronics. So all in together, the energy, semiconductor, these were robotics and mechatronics, all in aligned each other. So I wish to say thanks for everyone be present here. And then thanks for the opportunity given here. Thanks for Amrita Vishwa Vidyapeetham and Amma. Thank you, everyone.
Thank you, sir, for your inspiring words. Now, we invite Swami Achyutamrita Chaitanya, Principal, School of Spiritual and Cultural Studies, to hand over a token of appreciation to the chief guest.
We are delighted to have with us our guest of honor, Dr. Ramanathan Srinivasan, Managing Director of Automotive Test Systems. I request Dr. Gayatri N., Vice Chair, Department of Electronics and Communication Engineering, to introduce the guest of honor.
It is once again my honor to introduce the guest of honor for today, Shri Ramanathan Srinivasan, Managing Director, Automotive Test Systems, ATS, has been working in the automotive testing field for the last 3 decades. He's a director at Hexal Motors Private Limited and Transsion E-Automotive Private Limited, involved in development and manufacturing of commercial electric vehicles. He's also the Managing Director of Automotive Test Systems and BEP India Automotive Systems and Chairman of Piesler GmbH, Germany. He has established many an automotive lab and tech centers for automotive testing and validation. He's also a Vice Chairman at Society of Automotive Engineers, NIS, and conducts various events and seminars. He is very actively involved in various student educational programs and supports student competitions like Baja, FSC Cycle, Autonom, Reeve, etc. It's our pleasure to welcome you, sir.
Respected dignitaries on the dais, off the dais, students, professors, colleagues from the industry, a very good morning, and I would like to thank you all for inviting us here as a guest of honor. I come from automotive testing, as I was introduced. Thank you for the introduction, ma'am. And today I would like to present to you a little bit of some challenges and opportunities therein for you to contribute towards our Prime Minister's goal of having a Vikasit Bharat by 2047, which means the developed India by 2047. And because I come from the automotive industry, so I'll talk more about the challenges where you as a student or as professors or as startups can come and contribute for the success for our country to go forward in this particular technology. Can I have the presentation? Is it possible? So when I travel around across India, I mean, you guys also travel around, you see a lot of problems. One of your colleagues picked me up from the airport yesterday night. And he as well mentioned while we are going a lot of problems that he thinks that can be resolved. So today, the idea is just to present to you what are these problems. I mean, people keep talking about problems. I see them as opportunities for us to use technology today to solve them. And here, I think we have an audience from a lot of people from electronics and communication, electrical, computer science, and multiple branches. So an automobile is used to be only a mechanical product, and slowly developed step by step into something which is completely controlled by electronics. And today with the electric vehicles, obviously you have motor, battery, so and subsystems therein, like DC-DC converters and stuff. So it has become also electrical systems inside. And going forward, it is going to be like an iPhone or just a phone, right? So it is going to be completely software controlled. So going forward in a few years' time, you will see vehicles which are completely software driven. So it's a multidisciplinary product. So there are opportunities for many students or from different fields to come and contribute towards this success. I'll skip the introduction part of it. As I was introduced, I set up many laboratories. Only one thing that I would like to mention is one of the key important labs that I set up was in Amrita University. We tied up with Amrita University with the blessings of Amma 10 years back in Etimadai. And we have one of the best IC engine off late and EV lab we inaugurated last year. So anybody who develops a motor or an engine, they come to this laboratory for testing and validation of their product. So companies like Renault, Nissan, Ashok Leyland, Maruti Suzuki, so they all get their engines, quite a bit of their engines tested and developed here, including the latest hybrid engines that you will see in the Maruti vehicles. So those are all basically tested and validated at our tech center there in Etimadai. So to give you a sort of a glimpse of what an automobile development process looks like, that we first design a car, that means from the CAE side, and then comes into simulation. Then we start manufacturing components, and then we test those components to the performance that we want, assemble it into a product, which we call as a prototype, and then take it forward for different types of testing, for performance, for air conditioning, for example, passive safety, active safety. So we take it through a round of testing, and then we take it to the road as well onto the test tracks for testing before it comes on to the consumer. Yeah. So these are all the areas that we work with. These are all many tech centers we have established for all these different product lines. So today what I'm going to talk about is to sensitize you to the problem at hand, what I'm want to tell you. But before that, just to give you a perspective, yeah, so India's global production of automotive cars is increasing. So you see that today China is leading this market, and India is right now fourth in this list. You see that, but we are growing so fast that we are going to be very quickly into the number 3. Yeah, if you look at the segment-wise sales, we are today the world's largest manufacturer of basically two-wheelers, three-wheelers, tractors. In many of these segments, we are the largest manufacturers in the world. Okay, and you see a big chunk there from two-wheelers. You have to sensitize to these because this is where the problem starts. Yeah, because we have a large volume there of two-wheelers, three-wheelers, and the passenger car segment is just about growing. And if you look in terms of percentages, sorry, I think my colleague skipped one slide. Sorry, I think, how do I go back into the slide? There's an option to go back. This one, right? Apologies.
Are you able to go back?
Yeah, I'm able to go back now, sir. So what I wanted you to talk about is the automotive, the cars, for example, in a four-wheeler, you see there's such a low percentage of cars across. The number of people or percentage-wise who have access to cars is still around 8% at this point in time, and we are still in single digits. We are a population of 1.5 billion people. The infrastructure is growing, but still not enough to cope up. And imagine if even 20% more people have access to cars in the next few years, which is going to happen because you guys are all going to earn a lot of money and everybody is going to have the ambition of buying a car. So you're going to buy that. So which at the end of the day, with the large population which doesn't have a car as well, the accidents in India are unfortunately increasing, which means that nearly 170,000 people died last year because of accidents, which are registered FIRs, and a massive amount of people died much later than the accident, or they had brain issues, they had multiple issues with their hands or legs. 45% of them were basically two-wheeler riders, either causing the accident or dying in the accident. Yeah, more than 45% were involved in these accidents. So the reason I'm talking about is today in this conference, we are talking about robotics and mechatronics. So we need to figure out solutions to prevent these accidents, to save lives. And many of them are youngsters, very young people, young ages, aggressive drivers who want to ride bike for fun as well. And the other segment comes from people who are the breadwinners of their family, who go to their offices, earn money, and they come back home. Yeah, so they are the maximum users for two-wheelers, also in the middle age segment. So having sensitized you, so I would like to talk about the challenges. Sorry again. The challenges. Yeah. So as I talked about, I start talking about the traffic itself. So the traffic in India is already crazy. If you come to Delhi or Mumbai, or if you go to all cities today, we have traffic jams. Bangalore is a great example. Yeah. So because probably we don't have the right infrastructure for so many vehicles. And I'm talking about already only 8% of people having access to these vehicles, and still we have problems. So for you to develop a car which is software controlled with actuators, with robots, yeah, in the car, driving the car, which means you have to go around with the margins that are allowed in India. It's not like in Europe where they follow a certain safety distance. There are wide roads and the population is less, the density of vehicles is less. So here you will have vehicles moving from behind to forward to left to right in a very close manner, which means the algorithms that you guys need to write are very different from what you will write on a Tesla, for example, or some other car from China. It is very different. So you need to think about solutions as to how does your sensor and your algorithm handle this crazy centimeter by centimeter traffic. We have certain regulations in terms of testing or certain features. For example, the idea is to avoid collision, right? So how do you avoid an accident? It could be by braking, or it could be steering away from the accident, or maybe both. Yeah, steering and braking both. Yeah. So you need to understand all those computer science and electronics engineers. You guys need to understand a little bit about the mechanical behavior of this braking system or a steering system in order to develop the correct actuators, because there is a certain limit in performance. Even if you brake more than with a certain force, the vehicle is only going to behave up to that limit. So this is where we as engineers had to think about, okay, what is the limits of these vehicles? How can I control this vehicle? And if your camera completely detects people and tells you to brake, brake, brake in a city condition, you will always be braking in Indian conditions. That means that you need to use some kind of an AI algorithm to think about, how do we drive? How do you see? How do you think? Yeah, how does we think when we are driving in India? Yeah, so we talked about, advances in semiconductor technology and in terms of processing, which means we need to have very high-end processors inside the car to get this data across from the sensors like radar or camera or lidar, and then look at how do we handle our algorithm to process that data very quickly and to think the way that we think. So first is to see the way we see. It is very difficult to see the way a human eye sees. There are challenges. I'm going to talk about that next. The important thing is to understand how we think and how do you bring that across. So do you use multiple AI engines to process the data coming in from the sensors? And another one probably to just look at training, yeah, as to how should your algorithm behave on a continuous manner with the drivers. That means you keep on learning as an expert driver drives on the road, and you develop your algorithm further or the intelligence further into that. Do you use faster processing, for example, for the camera data? In the past, people used to only calculate distances with radar. Yeah, with camera, with image processing, it wasn't possible. But today, with this advanced computing power that we have, we are even able to calculate the distances with the camera. So things are improving. So it's only about somebody applying their mind across. So the first challenge I came in to talk about was the traffic. How do you bring that to solve the problem in your laboratory? Do you want to go to the road to do all this testing and to see this traffic? No. So we use simulation. And we bring the road, the traffic, all of this into simulation, the vehicle, all these characters. So just during breakfast, so I had a very good interaction during breakfast, because the challenge that we have in India is that we don't have data in simulation for these accident scenarios. So for example, if you have made an algorithm, how do you test it? Where do you test it? How many 100,000 scenarios do you have to test it to validate it? Because a person can go straight, a person can come back. There are so many different variations. Two people going, one of them coming back, one of them going forward. So different interactions are possible with people and with different types of vehicles as well. Somebody taking a crazy U-turn, somebody just stopping the vehicle on the road because the fuel is gone. There could be n number of scenarios. So you have to bring those scenarios across into your computer to be able to test and validate. Yeah. So looks like there are people in the market here in India who have recorded this data. And this is another challenge for you guys to annotate this data, label it as to what it is, and then to bring it into simulation in a way that is usable. That's why I put in traffic. And the next is the infrastructure itself. I was driving yesterday, and I went back nearly 30 years. 30 years back, I used to drive on roads where the traffic used to come from both sides. Of late, it is very rare for me to see in India roads where there is traffic coming from both sides. Yeah, and yesterday on the highway here, I was seeing that it is still that case, and that is very dangerous as well. Yeah, I'm talking about safety when I'm only looking forward, not worrying about vehicles coming from the other side, and still so many people dying. And now the challenge here I saw yesterday from Cochin to here was that the driving is from both sides on the same road. Yeah, so we used to drive like, to overtake, to take that risk of avoiding the incoming vehicle. Yeah, so this is even more crazier. So you need to think about lane marking for your autonomous vehicle, or when you divide a software-defined vehicle, you will say that, okay, if this is the lane, you have to maintain the lane, don't cross over to the lane unless you need to do an overtaking. You follow rules in software, yeah, to control the vehicle. But here I saw no lanes. So again, a challenge and an opportunity. So you have to think about an algorithm which sort of maybe measures the road width, different road widths in India, A class, B class, C class roads, different classification. think about how do you make a sort of a divider in between, an imaginary divider for your software, and how to bring it in. Another thing that is causing a lot of deaths is trucks parked on the road at night and vehicles coming in and crashing it from behind, including buses, and many people dying. This is happening very frequent, at least in near Delhi, in the Yamuna Expressway and many other expressways as well. So if you can devise an app, okay, wherein whoever is parking a vehicle on side of the road, if they can just put it across on the app that, I have parked my vehicle over here and this is where I am, be warned to all the other ecosystem. We're talking about connected vehicles here, that every vehicle is connected. Today, we all use Google Maps. So if there is a way to inform the others that you are there, already incoming vehicles will be warned that there is a vehicle standing and to be careful while driving in that patch. So these are typically opportunities to come up to solve some of these problems where you can do some research and come out with a solution. The next is, of course, the road behavior itself using AI, because the driver model is very important when you train your AI model in terms of driving the autonomous vehicle. Yeah, maybe I drive aggressively. There are people who drive really slow, even where in a highway you are supposed to drive at 100, they drive at 50 kilometers per hour, 30 kilometers per hour. Okay, and we have this bad habit of driving only on the right side sometimes. Yeah, because that is an overtaking and a high-speed lane, we drive slow. Yeah, and our driving behavior is very different. Some people just want to overtake and move, and some people just want to follow the rules and just drive slowly. So everybody behaves differently. So these are very different driver models from the driver models that I see in Europe. Yeah, where everybody is sort of trained in the same way, that if there is an intersection, this car will stop, come what may happen. And he will look, he will let the other guys pass, please go, and then the person will go. Here it will be like, I want to go first. Yeah, so I want to win this at least. I have not won it the first class in college, so maybe I'll win it on the road by this guy. I'll go first. Yeah, this is the kind of attitude that we have, a very aggressive attitude in terms of moving ahead. We want to go as fast as possible from point A to point B. So this kind of behavioral, let's say, aspects that are peculiar to our country should be brought across into this particular model. If you can even do a research only on this, that itself is a big benefit to the country, to bring in different driver models. And then I'm talking about the environment itself. Yeah, environment is a big challenge. So when you develop sensors, you need to be careful about that these sensors or ECUs have to work under harsh conditions. I remember when we used to work on a project with Ashok Leyland, those were the first ECUs coming into the vehicle. And the way a truck or a bus is shipped is not that it is made, fully bus is made. Just the chassis is manufactured by Ashok Leyland, shipped across to a bus body builder who builds the bus. So the chassis with just one seat and just an empty chassis, there is nothing there, no seats, nothing, just one seat for the driver, and everything is exposed to the environment, would go in. And we put in the first ECUs, they would fail. Again and again, they would fail. With the heat, with the rain. So we figured out that the electronics to work in India, you need different kind of specifications in terms of humidity, in terms of temperature, in terms of all the extreme conditions that you can think about. So, and for the sensors itself, think about a camera working at night. Think about a camera working at extreme temperatures. In fog, where a maximum accident happens in the north and in the mountains. So think about solutions where you can develop electronics which can work under these conditions. And these cameras are mounted outside. And think about what happens during rain when the car ahead of you puts mud into the camera lens. So think about solutions where you can wipe it off as well. So that's why, I mean, this is what I wanted to talk about today, to sensitize you that there are opportunities in manufacturing of sensors. India doesn't manufacture many of these sensors, we import. So of late, yes, one of my friend, he manufactures radar sensors in Pune, which we are giving to students to put in their vehicles and develop autonomous technology as part of our Baha competition that I conduct, inter-university competitions that we conduct. Yeah. So where the challenge is to develop a fully autonomous vehicle and compete with other universities across India. So the radar, we have just started. Cameras, we still import. So today we talked about manufacturing of semiconductors in India. So if this is happening in a big way in India, it is going to happen now. So can you guys come up with solutions? Can you guys think about manufacturing high-end cameras, high-end LiDARs? I used to work on a project with a company called IBEO. It was later taken over by ZF. This was a challenge by BMW. I think 10, 12 years back, I worked on this project where they wanted us to develop a LiDAR sensor, which gets me the benefit of radar as well as, camera with a 3D point cloud for 100 euros. Those times the euro was about maybe 50 odd rupees. Yeah, so 5,000 rupees or 6,000 rupees is what was the challenge. Still not made. Yeah, so today people are selling it at extreme costs in lakhs of rupees. So can you develop a LiDAR sensor here at Amrita University and showcase it in the next conference about as a product here, as a LiDAR sensor? This is what the country needs because the camera doesn't work in all scenarios. The radar doesn't work in many scenarios. So we have to use multiple sensors, which adds to the cost of the vehicle. People don't use LiDAR because of the cost. And the automotive industry is extremely cost sensitive. Yeah, the future of the car is going to be like your, you use TVs, right? Today, smart TVs where you download Netflix and Amazon Prime and things like that. And you subscribe and pay for what you use. So the car is going to be like that. So depending upon what feature you want, you can select from your phone that this is the car I want. You don't even need to buy it. You can just order a car to come to your home. And you can say, okay, I want it from this time to this time. And this is what I want inside my car. I want this feature, this feature, this feature. I want air conditioning. I want this, and you pay, you subscribe. And the cost of the car is not going to depreciate. As you develop the software further, the cost will appreciate. Yeah, this is going to be the future. So, all right, so to sensitize a little bit more in terms of sensors, yes, in terms of hardware, you know that we're talking about ECUs. I think you guys have already working with NVIDIA boards and things like that, right? So you can at least start working with controllers. And you guys, I think many of you are working on robotics now. So I'm sure that you guys are sensitized towards using the right kind of hardware for processing. The important thing for you to know is not to use conventional stuff. People take camera data with electronics guys. I think you understand DSP and image processing. So people are still processing the data at probably 30 hertz. So can you think about processing it at 1000 hertz? Can you put in AI to predict as well as to how that human behavior is going to happen? For example, the professor was working on a project. He presented in one of our conferences where he was working on the signs and the facial expressions to see if that person is going forward or back. Yeah. So if you go to Chennai, the auto driver to turn right, this will be the signal. Yeah, the leg. Yeah. In Delhi, the e-rickshaw guy looks like this. Yeah, like this. That means he is going to turn immediately right. All right. So this is what is India. You cannot change this. But you can simply say that I don't want to bring this technology in, or we can look about it as a problem that we can solve with the help of AI. It's up to us as to how do we perceive it. All right. So, and the next one is the stack itself. Yeah, I talked about it using AI for the stack development itself when you talk about controlling the car. So the stack itself can have different ways of working in because the car is now connected. You get continuous data. You look at objects and you see when is your camera detecting it? What are things that you're missing out? Things like that that you can study from multi-sensors in the car. And you can keep on optimizing this data on the cloud. So the concept should not be a black box. So today the challenge is some German, let us not even talk about one country. Let's say some companies who understand braking system, steering system, who develop the controllers for them, they control this market. The reason, if you bring in your software for autonomous driving, you have to interface with their hardware. Interfacing is not a big deal. So they provide black boxes. So they don't even provide black boxes, open boxes to even companies like Tata, Mahindra or Maruti. They don't. They just give black boxes. This is what is this. This is my sensor. This is the system. Take it. And now you tell me, oh, this is not working. We need to tune it. They will ask for money to tune it. This is a massive business. So why I'm telling you this is you need to sensitize yourself as to how do you now use controllers with actuators. What we don't have in India still is made in India actuators. You use robotics, you're using actuators all the time for these applications. Think about the application of using the actuators for controlling the pedals. Think about drive by wire. Okay. Think about steer by wire, where you can just steer with a stick. Yeah. So think about getting in actuators, developing actuators with the hardware. That is completely missing in India. So only companies who have developed these, they are controlling this market. And because they don't still understand India, none of the vehicles in India have a product which is fully working. So if you cross the road and somebody says, my car has ADAS, it is not going to crash, don't believe. Yeah. I test these cars every day, and more imported cars fail than even Indian cars. I can tell you this. Okay. The more I test it, we are all learning together. So this is an opportunity because the industry also doesn't know. The vehicle manufacturers are all mechanical engineers, right? And now they are suddenly understanding there is cloud and there is actuators, there is AI, and these guys are going crazy. They are all getting in new departments for software. So there is a massive opportunity here for electronics, electrical, and software. So you guys can have a great career if you are interested in this. And on top of this now comes cybersecurity. Because once you have a software defined car, I can hack in and take your car away. Yeah. So cybersecurity becomes very important. All right. So there are massive amount of opportunities in all these domains because we from the automotive industry, luckily I also did ECE. Yeah? So that is why, I am able to understand at least these problems, what is going on inside, whereby I see an opportunity and I make a lot of money because I understand this. Yeah. So you guys have an opportunity here to bring about your solutions into this or to make a career into this. All right, so just to give you some scenario, this solution I already found, this was to sensitize you towards this traffic scenario in India. I'm not sure if the video plays today here in this presentation. I wanted to show a video here where on one side, on the left side is the cars, which are real cars, which we are recorded. And then on the right side is that I brought in those vehicles across into my simulation environment. Yeah. So this is not just simple camera recording. You need to have the position of the other object, the speed of the other objects around and things like that. And then use AI to actually to think about whether that is a pedestrian or a car or a building or what kind of a signboard and things like that. So yeah, so we develop algorithms to bring this in. So, all right, then just to show you something, because this is an IEEE conference, so I just thought, okay, normally in IEEE conferences, I talk more about electrical and electronics in terms of electric vehicle development. And what I want to show you is think about always innovating. There are many people doing the same thing. So you need to be a little bit different from the herd and you need to stand out. So a couple of examples, they talked about a couple of companies that I have invested in to show you in terms of EV also, we have similar challenges. India was highly dependent on motors from China. I think you've been reading on newspapers, right? Rare earth everywhere, and China blocking magnets and things like that. The motors have magnets. Yeah, you need batteries, you need lithium and things like that. Yeah. So me from electronics, I didn't understand chemistry in the past, but now, of course, I'm looking at everything is basically sensor, then controller, actuators. Either it's an open loop or a closed loop control in this case. Yeah. So, and then the software itself, and now on top comes AI and cybersecurity and things like that. So the structure for everything is the same. It could be that the reaction is chemical and then you get some kind of a signal, a current or a voltage or something like that, which we need to process. Either it is too small so that you modulate it and then demodulate it. That depends on us as to how do we process the signal, right? You guys understand amplifiers and you guys have read about all those stuff. So, all right, so we have challenges in terms of motor controllers. Only off late, India has started developing motor controllers. We have started developing induction motors. We used to use it for pumps in the fields, the induction motors. But today, the induction motors are being used in the automotive application. Switch reluctance motors. If you've studied in school, we talk about motors and generators, BLDC, yeah, brushless DC motor and things like that. So it is the same stuff, what we studied there, Ohm's law. Yeah, simple stuff. We have high voltage systems, you reduce the current, reduce the heat. So the challenges are more thermal here. Yeah, so you want to use high voltage systems in this case. There are opportunities in this area. So, all right, here you see some of the vehicles we made. We decided that we don't want to make a vehicle like a Tata Ace. We don't want to make an auto rickshaw. So we decided, okay, we make something which is by regulation allowed as a three-wheeler, but it gives me functionality of a four-wheeler. So I brought two wheels together to less than 460 mm. So there was a loophole in this regulation which says that this twin wheel can be called as a single wheel. So this improves my vehicle dynamics in terms of handling. I can climb up the mountain and things like that. I can carry bigger payloads, working like a four-wheeler, but I'm selling it at the cost of a three-wheel, a little bit more than the three-wheeler. Yeah, this is sort of a small innovation. The challenge for you guys here, if this video works, is maybe it works. No, maybe it does. Can you see this wheel over there? This vehicle over there? Can someone tell me where the motor is? You understand that a vehicle has a motor. This motor is either a mid motor or a hub motor. So we can either put it on in the vehicle in the middle somewhere, having maybe in the front or the back, depending upon how the vehicle is designed, a car or a two-wheeler, that you have a motor. And where is the display? Where is the speedometer? Can somebody see a speedometer over here? No, you won't see it. You won't see the motor as well. The motor is inside the tire. It's a hubless motor. Yeah, there is no motor. You see an empty stuff over there. That plate, that the motor is over there, in there. Okay, and yeah, so we have used a helmet where the entire display comes in the Google Map and everything comes across on your the helmet across. So there is nothing over there. The battery itself is in the front where you see normally you have a space to store some stuff. That is my battery over there. So it's been designed in a little bit different way. I thought, okay, let's make a two-wheeler which is a little bit different in terms of technology. It is fully connected. That means every second that gives across data across to me, and I can now play in the cloud with this. Yeah. So all right, just to tell you, you need to innovate. There are a lot of problems in the industry that we are trying to solve. And in this conference, you are going to have the best speakers coming across and talking about their technology. Why I talked about all of this is for you to understand these are challenges, and you guys need to ask questions to understand how any one of them can help you to solve one of these problems if you're interested. In terms of semiconductor, in terms of actuation, or in terms of software, in terms of AI, it doesn't matter what. There are plenty of opportunities for you in the next 2 days to learn a lot, but not sitting quietly in the audience. You need to ask questions. All right? And try to learn as much as possible, get connected, and try to see if you can come across as one of the industry leaders. I'm sure that many of you will, and solve some of these problems. Thank you so much.
Thank you, sir, for sharing your valuable perspectives on the growing trends in automobile industry. Now, we invite Dr. S.N. Jyoti, Associate Dean, to hand over a token of appreciation to the guest of honor.
We have here Swami Achyutamrita Chaitanya, Principal, School of Spiritual and Cultural Studies, for the benedictory address. I request Dr. Gayatri N., Vice Chair, Department of Electronics and Communication Engineering, to introduce Swami Achyutamrita Chaitanya.
It's my pleasure to introduce Brahmachari Achyutamrita Chaitanya ji to you, although Swami needs no introduction. Brahmachari Achyutamrita Chaitanya serves as the principal of the School of Spiritual and Cultural Studies and as an associate professor in philosophy, arts and culture, and spiritual studies at Amrita Vishwa Vidyapeetham, Amritapuri campus. He joined Amrita in 2011, following over 2 decades of dedicated teaching service at MA College, Kodamangalam, under Mahatma Gandhi University, Kerala. He holds an MA, MPhil, and PhD from Cochin University of Science and Technology, with his doctoral research centered on Ramcharitmanas and the Bhakti tradition. Drawing from this rich academic and spiritual foundation, he has delivered numerous discourses across Kerala and in various centers of Mata Amritanandamayi Mutt, sharing insights on devotion, culture, and Indian philosophical heritage. His work harmoniously blends traditional scriptural wisdom with contemporary academic inquiry, fostering value-based education and holistic cultural understanding among students. I heartily welcome Swami to the dais.
Om Amriteshwarye Namaha. I bow down at Amma's lotus feet. My salutations to the experts on the dais and off the dais. My greetings and a very good morning to all the participants, delegates of this seminar on robotic and mechatronics. To be frank, I am not a person to speak anything about these two modern technology branches, emerging technology branches. Maybe at present they are not emerging, they have emerged a few decades before, like robotics and mechatronics is somewhat new for me at least. But what I would like to tell you, I will speak only for some 5 or 6 minutes. What I would like to share with you is Amma's vision about all these things. You know, Amma, my master and mother, Mata Amritanandamayi Devi, is the chancellor or Kula Guru of this Gurukula. In ancient traditions, we have Gurukulas. We had a lot of Gurukulas in our this sacred land, Bharatavarsha, in which thousands of students studied in the Vedic period. The Gurukulas of Yajnavalkya, Sandipani, or for that matter, many great Vedic rishis and Puranic rishis had big Gurukulas. And later you might have heard, at least our students might have heard of the famous universities in Takshashila, Nalanda, Vikramashila, Kandalur. All these places had very huge universities in which all types of knowledges were imparted to the students. So keeping that tradition, Amma is also giving all types of knowledge to the students, to the seekers. So there is a very ancient statement in our scriptures from Mundaga Upanishad, which is a part of the Vedas, dating back to millennia. In the Mundaga Upanishad, there is a statement, Dve vidye vedidavye brahma vido vadanti sma. The Brahmavids, the knowers of the ultimate reality, Brahma, the substratum of the universe, those who have known it, those who are established in that Brahma, that the supreme reality, they say that 2 types of knowledges has to be learned. Dve vidye vedidavye. It is mavadanti brahmavidaha. So 2 types of knowledges has to be learned. This is not the opinion of any scientist or any politician, any king, any businessman. This is the opinion of Brahmavids, the realized souls. What is their opinion? Though 2 types of knowledges has to be learned. Parachaiva paracha. One is paravidya and the other is aparavidya. So this paravidya is the knowledge of the Brahman itself, knowledge of our true nature, the secret behind the universe. And the aparavidya is listed in the Chandogya Upanishad, which is also a very ancient Upanishad, ancient, maybe part of the Vedas, which dates back to millennia, 2 or 3 millennia at least. So there the aparavidyas are listed like all types of knowledges other than the knowledge of the self. Like there is Vastu Vidya, there is architecture, there is drawing, Chitra Vidya, there is Sahitya, there is linguistics, there is grammar, there is Vaidya, medicine, and there is Yandra Vidya, Tantra, all types of knowledges which are considered secular in the modern perspective. They are all listed there. Some 64 vidyas are listed in that Chandogya Upanishad, which contribute to the Apara Vidya. So these two types of knowledge, the knowledge of ourselves as well as the knowledge of everything else, has to be learned according to Vedic tradition, according to the advice of the rishis. So Amma, in strict line with these teachings, is promoting both of them equally. That is why this great institute or the organization has produced many institutions for advancing knowledges of contemporary relevance. Like modern medicine is there and Ayurveda is there. Shilpakala Kshetra is there in Trivandrum, and architecture school is there in Etimade campus, Coimbatore campus, School of Architecture. So all types of knowledges, ancient and modern, which are conducive to the advancement or development of the society, is promoted by Amma. And you might have noted that the center which is conducting this seminar is Humanity for Technology Labs. So what Amma adds to the technology is humanity. Amma's message is compassion is the beginning and the goal of spirituality. Amma says, കാരുണ്യമാണ് ആധ്യാത്മികതയുടെ ആദ്യവും അവസാനവും. So Amma wants to put or synchronize compassion to the whole creation into technology, science, and all other types of knowledges. So this vision is there behind all of our activities, all the activities of Amrita University. And in the 2 days coming, you will be familiarized with or introduced to many new trends in the fields of mechatronics and robotics. And you all will be benefited by attending these 2 days seminar. And as mentioned by the expert speaker, you have to speak out. You have to express. You have to open up so that you will get the knowledge. Because Vidya comes only through learning, through studying, as well as through expressing. That is very important. Saraswati Devi eradicates avivekam. Avivekam Didiyaja Kirtanat Sravanat Tatha. You have to listen as well as you have to express also, to vocalize also. Then only knowledge will come to us. For these types of seminars and conferences are arranged, the platforms are set by Amma's grace. And I take this opportunity to congratulate Dr. Rajesh Kannan for taking the lead in organizing this seminar also. And I wish all the very best to all the participants, delegates, expert speakers, guests of honors, and and you can expect very fruitful 2 days ahead. With these words, I offer my words at Amma's lotus feet. Om Amriteshwari Namah.
Thank you, sir, for your kind words of wisdom.
We are deeply honored to have with us today Dr. B.S. Manoj, IEEE Kerala Section Chair, with us to the ceremony. Your presence adds immense value and inspiration to all of us gathered here.
We will now watch a brief video presentation showcasing the achievement and initiatives of HUT Labs, Sustainable Mobility and Automotive Research Technology Smart Center, and Amrita Coconut Research and Development Accord Center. A short note, all the robots showcased in this video are on display in our robo exhibition section. We welcome you to explore them at your convenience.
We now move to a moment of pride and purpose. Distribution of 2 AI-based coconut dehusking machines to the beneficiaries, completed as a part of collaborative project between Accord Center, Hut Labs, and Parachute Kalpavriksha Foundation, Coimbatore, funded by IEEE EPICS. Now, we will watch a short video demonstrating the functioning of these machines.
So this is the AI-based coconut de-esker machine developed by Amrita Vishwa Vidyapeetham Hut Labs and in collaboration with the Parachute Kalpavriksha Foundation. The user places the coconut with the husk in the roller. The roller is powered by a very high power motor which DS, and the A part before DS identify whether the coconut is matured or not. So non-matured coconuts cannot be DS. So only matured coconuts we need to DS with this machine.
Parachute Kalpavriksha Foundation is a non-profit organization dedicated to improve the lives of Indian farmers. The foundation currently supports over 65,000 farmers, covering nearly 2.75 lakh acres of plantation across Tamil Nadu, Karnataka, Kerala, and Andhra Pradesh. With a team of more than 100 agronomists, it promotes scientific and sustainable farming practices through regular field visits and personalized guidance. In addition to productivity enhancement, the foundation undertakes initiatives such as water conservation, farmer training through the Kalpavriksha Knowledge Center, and expert advisory support. Through these efforts, Parachute Kalpavriksha Foundation continues to make a meaningful difference in strengthening India's agricultural community. Now, I request our chief guest, Mr. Kannan Rajput Sampath, to hand over the machine to the beneficiary, Parachute Kalpavriksha Foundation, Coimbatore. Mr. Shaji Kumar, Manager, Sustainable Agriculture, Parachute Kalpavriksha Foundation, will receive the machine on behalf of the beneficiary.
Thank you, sir. The second machine will be received by Swamini Rema. Swamini Rema is currently overseeing the operations of the coconut unit in Ashram, where approximately 1.5 lakh coconuts are received every month from various regions. In addition to meeting daily household needs, these coconuts are processed to produce pure coconut oil, which is widely recognized for its health benefits and medicinal value. The coconuts are used to prepare a variety of nutritious side products that support local food and wellness traditions. To enhance efficiency and reduce manual labor in the processing workflow, it would be highly beneficial for the unit to receive the coconut dehusker machine developed by Hut Labs. This machine will support Swamini Rema's ongoing efforts to streamline production, improve output quality, and expand the health-focused coconut product line. This will also help the local community in dehusking the coconut.
Now I request our guest of honor, Dr. Ramanathan Srinivasan, to hand over the machine to Swamini Rema. Let us celebrate this meaningful collaboration between technology and community. A heartfelt congratulations to Hut Lab and all stakeholders involved. Please give a huge round of applause.
To honor this occasion and share their valuable thoughts, we now invite our distinguished guests for the felicitation address. We request Dr. Manoj B.S., Chair, IEEE Kerala Section for the felicitation address.
Thank you. Pranams to Mada Amritananda Devi. Pranams to Brahmachari Achyutamrita Chaitanya, our chief guest, Sri Ramanathan Srinivasan and Sri Kannan Tajpur Sampath, Dr. Rajesh Kannan Mahalingam, Dr. Jyoti, Dr. Remya, other dignitaries here, faculty members and students of Amrita University, IEEE members, delegates of this ICRM 2025, a very good morning to one and all. First of all, I apologize for missing some part of the inaugural session. Despite my best planning and preparations to start early, the construction work from Trivandrum to Karunagapalli have been much more complex than I could imagine and estimate. Apologies for that. Maybe it's Amma's blessings that helped me to be here before the function getting closed. Thank you very much for that. So it's a pleasure to be on any event at Amrita University, both technically and professionally. As you may have already seen, one of the IEEE EPICS funded projects that has materialized as a product. I have seen several funding of IEEE EPICS project. I have been part of the selection committees of IEEE EPICS related projects. But rarely I could see a product reaching the end users. Like the one product that came out of Dr. Kannan's lab, Hut Lab, which is one of the most cherishing moments that a university is able to, that a research lab is able to touch and enhance lives of ordinary citizens. There is no bigger accomplishment that can be made beyond that. I'm really glad that IEEE Kerala is a technical co-sponsor for ICRM, and we are delighted to continue our support for these events. This year, IEEE Kerala section has introduced several remarkable activities, new activities. One of that is IEEE Summer Internship Program, which trained more than 1,000 students across Kerala in 2025 summer. We also have introduced international travel support for students and professional members of IEEE Kerala. And in the most recently concluded IEEE 10Con in Malaysia, we have been really glad to approve more than 1 dozen IEEE members, including that of faculty members and students, to attend the IEEE 10 in Malaysia. So similarly, IEEE Globcom in Taiwan, or many other conferences, we have been able to generate new revenue streams and support students and faculty to attend international conferences as well as national conferences. That is a new initiative that we have started. As you know, we have crossed a, a milestone of 16,000 members of IEEE in Kerala, which is the highest ever we have seen in the last 50 years of IEEE Kerala's existence. I appreciate and congratulate all the volunteers, student branch counselors, student branch chapter advisors, including Dr. Kannan Mahalinga, who serves as a student branch counselor of the IEEE student branch of Amrita University, for making this accomplishment a reality. So we conduct 4,500 technical activities every year, leading to something like more than a dozen activities every day in Kerala, and thereby becoming the non-governmental, non-university organization which is imparting technical training, skilling to engineering students in Kerala. Early this year, when I took charge as IEEE Kerala section, with the votes and support from most of the members, we had studied the engineering ecosystem in Kerala. Kerala had internationally ranked institutions and nationally top ranked institutions like Amrita University, to very rural engineering colleges funded by trusts or individuals training our engineering graduates. We found that while most of the national institutions and the universities like Amrita University do not face a crisis including student enrollment, our rural engineering colleges were facing serious crisis in terms of student enrollment. So we started working with the government as well as the managements. We started creating a campaign for enhancing the enrollment. And as a result of a series of sustained activities, we have enhanced the enrollment in Kerala's engineering colleges, particularly the KTU system colleges, by about 5.22 percentage. That is something about 2,500 new engineering students into our engineering classrooms. So many colleges are now in a better place situation. The next year in 2026, we are targeting even better enrollment in engineering education across the KTU system colleges as well as the premier universities like Amrita University, so that we will be able to create more engineers to serve the society. And when we talk about engineering education, one of our long-term goals in IEEE Kerala is to make Kerala a higher education destination. To make Kerala a higher education destination, a credible brand building for the higher education is very, very essential. And IEEE Kerala has identified 4 value pillars reflecting Kerala's engineering education. First being that Kerala's engineering institutions have highest quality curriculum in their engineering programs. The second point that we identified is the teachers' quality, and teacher-student ratio is actually much better in Kerala's engineering institutions than outside the Kerala engineering institutions. The third is actually highly affordable education. Kerala's engineering colleges charge a fraction of the fees that typically charged by the competition elsewhere outside Kerala. And the fourth being that Kerala's engineering institutions train students for the global talent pool and with much better level of placement. So by these 4 points of value, we are actually initiating a long-term brand building of Kerala's academic and engineering institutions with the help of the universities, engineering colleges, Kerala government, and all stakeholders involved. And as you know, IEEE Kerala section is beyond just technical activities, beyond funding R&D projects, beyond funding travel support, and it's also into helping students conduct get better placement too. So we conduct a launch party every year. 600 to 800 students get placement in a central way, where students from all engineering institutions from Kerala can participate and get a placement opportunity, in addition to the placement opportunities that they can avail from their own college resources. So with all this, we are able to support the engineering education in Kerala, engineering faculty members in Kerala, and the goal of Kerala becoming a higher education destination in the long run. We need to work with the government. We need to work with the universities. We need to open up our engineering classrooms to students from all around the world. I have seen our students going to all European countries, all American, North American countries, or even now our students are going to China to get a higher education degree at a much higher fees that they charge. Okay, now we want to open up our higher education classrooms, including masters, PhDs, and other degree programs to students population from all around the world, so that India can once again become the higher education destination of the world. So we would like to request everybody's help and support in our IEEE Kerala's mission for making Kerala a higher education destination, as well as India a higher education destination of the world. Thank you so much for listening. Thank you for inviting me over here. Thanks to Dr. Kannan's leadership in HAT Lab and in organizing a quality conference like IEEE ICRM 2025. Thank you.
Thank you, sir, for those inspiring words. We now invite Associate Dean Dr. S.N. Jyoti to share her valuable thoughts.
Om Amriteshwariye Namah. Good morning, all. Distinguished guests, Sri Kannan, our guest of honor, Sri Ramanathan Srinivasan, Brahmachari Achyutamdadaji, our IEEE sponsor, Dr. B.S. Manoj, he is the chair IEEE Kerala section, Dr. Remya, my dear faculty members, all distinguished participants of the conference, dear students. Now, actually, I am actually excited in these 2 hours itself. So you can imagine the going to be 2 days getting rich informations, ideas. So what? So my request to students is to use this opportunity and also at the same time note all the information that you are getting. It should not even be in your mobile. You have to write what you are getting in these 2 days. And I'm sure that we'll be able to support you in getting support in moving with these ideas from industry, from research organization, what else? I wish to congratulate Dr. Rajesh Kannan, who have been discussing this with us for last 1.5 years, getting sponsorship from IEEE and other organizations. And it is really a moment of privilege and honor for Amrita Vishwa Vidyapeetham, Amritapuri campus, School of Engineering, to have this many number of key speakers and participants And what else? That itself is the quality going to be of this conference. So congratulations and best wishes to all of you. And I will also be using this opportunity along, together with all of you now and then. Now, I'd like to share about our university, Amrita Vishwa Vidyapeetham, the first school of engineering of our university was established in 1994 at Ettimede, Coimbatore. And now, as on now, we have 10 campuses in the A to Z alphabetic order. It starts with Amravati, Amritapuri, Bangalore, Chennai, then Faridabad, Medical Plus, Engineering Campus. Then it comes to Mysore, then Nagarkovil, then it goes to Kochi, and the latest addition is Haridwar, the engineering campus. So, about our campus, Amrita Vishwa Vidyapeetham, Amritapuri was established, School of Engineering was established in 2002 with 3 programs: BTech in Computer Science Engineering, Information Technology, and Electronics and Communication. And the total intake was 180, 16 batch. But that year, we got only 108 plus students. And now we have, as on 2025, 8 schools: School of Engineering, Computing, Biotechnology, Business, Physical Sciences, Spiritual and Cultural Studies, Arts and Humanities, School of Ayurveda. So 8 schools, more than 11 centers of excellence, and many clubs introduced, from Robotics Club, ACM, ASME, Environmental and Energy Clubs, then ICP, the FOSS Club, BIOS Club, which is a security club. It goes on. So, and now we have from 108 plus, we are about to cross 7,000 students in these schools. It's all Amma's blessings. I can't believe, because I'm also very lucky to be part of this development activities since 2002, because my husband, Dr. Shankar, happened to be the first principal, first faculty to join in 2002. And he retired just after his 24 years of service as a registrar, Amrita University. So I'm very proud to stand here. And this is actually Amma's blessings to have a teamwork of faculty, students, and staff in this growth. We have been going through all accreditation process, NAC. We got, now we have NAC A++ higher grade. 6 years they used to give. We got 2 years for excellence. So 8 years we have NAC A++. We have completed NIRF since 2016. Now we stand in the first 10. That's 8th position this year. And we have also completed the National Board of Accreditation requirements. Now, what else are all possible with the support of all our faculty, staff, and students. And we have also so many recognitions through faculty and students. Recently, now we have got for the world robotic competitions, the team of Dr. Rajesh Kannan and students, they have won first prizes in several areas in the robotic competition. Then in the cyber security competition also, we have held at Korea. We have won first prize and best prize, like that way. So we are encouraging our students to participate in co-curricular activities and also extracurricular activities, sports, and cultural activities. And these are all possible with the support from our campus director, and higher authorities, Vice Chancellor, and many others in the team. Then now you might have heard from Dr. Rajesh Kannan and other speakers about the opportunities for our students to take part in internship in our centers of excellence. And we are providing internship for our own students and other students also during vacations. Now, the unique feature of our curriculum is Dr. B.S. Manoj already told that we should have a quality curriculum. So we also focus on our curriculum, but we have some compassion-driven curriculum. Like uniqueness is experiential learning, and we call it as Living Lab and also student social responsibility. So Living Lab is a 3-credit course in their 4th and 5th semester in our curriculum, and students who are interested to go to villages, they will be given 1-week workshop in the campus, and after that they have to go and stay there in the village, identify the problems of the village, come back and then find solutions for that. At the same time, they should publish a research paper or a patent based on that, or they should write some funded projects, and it should be extended to a society also. There should be a compassion-driven societal contribution from our side. So all our researchers will be extending for the beneficial of the society. Then this year is very special for us because we gave a lot of importance to environmental pollution and control. And for our initiative in net zero carbon emissions in the educational campuses, then best waste management practices, this in 2025, we have received 8 awards for our practices from various organizations like a Directorate of Environment and Climate Change, Sujita Mission, Haritha Commission, Kerala State Pollution Control Board. And these are all possible with the support of academic community, staff, and students. So with this, I think I'm able to give a small briefing about our university and campus. Welcome all. Have good time. If at all anyone is having any problem, now you can share your problems to the student coordinators, and we are ready to support you in every way. Have a good time, and the successful participation of each and every one of the participants and the students is the success of going to be of this 2-day conference. Wish you all the best. Thank you. Namah Shivaya.
Thank you, Dr. S.N. Jyoti, ma'am, for the felicitation. Now, I invite Brahmacharini Dr. Ramya, Chairperson, Department of Electronics and Communication Engineering.
Om Amriteshwaraya Namaha. Namaskar, all of you. Distinguished Chief Guest Shri Kannan Sampath, CEO BioWMS Chennai. Guest of Honor Shri Ramanathan Srinivasan, Managing Director ATS. Dr. Manoj BS, Chair IEEE Kerala Session. Dr. Jyoti SN, our Principal and Associate Dean. Dr. Achyutamrita Chaitanya, Principal, School of Spiritual Science. And Dr. Rajesh Kannan, Professor and Director of HUT Lab and related research centers, and also the Chair of ICRM 2025. Distinguished keynote speakers, my dear faculty, students, as well as the participants from various campuses. So it is with an immense pride and joy that I stand here today alongside with all of you at this IEEE International Conference on Robotics and Mechatronics, ICRM 2025. We have already heard from our esteemed speakers about the importance of this gathering and the value of having a strong networking platform like this. So this conference truly serves as a global stage of collaboration, innovation, and meaningful exchange of ideas among researchers, engineers, and professionals in the dynamic field of robotics and mechatronics. So I'm delighted to witness the depth and originality of the various research papers submitted for the conference, out of which we could only select a few percentage. The conference program featuring keynote addresses, technical paper presentations, hands-on workshops, and vibrant student competitions create a rich ecosystem for learning and exploration. These 2 days will be an inspiring opportunity to meet experts across the domains, as I was mentioning, exchange knowledge, and refresh our perspectives on emerging technologies. Such interactions not only expand our understanding, but also ignite curiosity, nurture creativity, and strengthen the gap between industry and academia. I'd like to express my sincere appreciation to the organizing committee, the reviewers, and the volunteers for their dedication and meticulous planning. My heartfelt thanks also go to IEEE Kerala section for their continuous support and encouragement, which has played a pivotal role in making this event possible. Our Chancellor, the world-renowned humanitarian leader, Sadhguru Mata Amritanandamayi Devi, our beloved Amma, always reminds us that science and spirituality are not separate paths. They complement and elevate one another. When we work on designing a robot with sincerity, focus, and total dedication, the process becomes meditative. As Sir was mentioning, when that innovation is driven by the intention to solve societal challenges, Sir was mentioning about how we will identify a mechanism to solve the accidents, and when that innovation is driven by the intention to solve societal challenges, compassion becomes the guiding intelligence behind technology. So a platform like this, ICRM 25, sharpens our skills, removes our limitations, and molds us into responsible and sensitive engineers. So today we often interact with Gen AI and assume the conversation is just between we and the mobile phones or the laptop windows. Yet behind that one query that we put in the chatbot lies a vast network of data centers powered by thousands of processors and countless hours of engineering excellence. What seems simple on the surface is supported by immense unseen human effort. So similarly, when we look at a robot, we often notice its outer actions. But the real intelligence lies in its embedded system, its sensors, processors, circuits, and obviously the algorithms that runs it. So every movement of the robot is a reflection of human creativity, discipline, and passion. So thus, when we design a robot or build an embedded system, we are not merely assembling the hardware. We are bringing ideas to life. We are merging science with purpose, technology with compassion, and engineering with humanity. And it is in this spirit that innovation becomes more than advancement, it becomes true service. So to all the participants, congratulations. I applaud your hard work, dedication, and vision. Each of you represent the future of robotics and engineering. I'm certain that you will carry many valuable takeaways from this conference that will contribute meaningfully to your professional growth and research journey. Wishing each one of you an inspiring, intellectually enriching, and memorable experience at ICRM 2025. May the connections you form here and the insights you gain from here continue to guide your works in the years ahead. Thank you. Namaskar.
Thank you, Brahmacharni, Dr. Ramya ma'am, for those kind words. With that, we conclude the inaugural function of ICRM, a morning filled with inspiration, innovation, and meaningful collaboration. We will now break for refreshments. Kindly join us for tea and snacks arranged outside the venue.
Please reassemble by 11:15 a.m. for the upcoming sessions. After the tea break, keynote sessions will take place in Amriteshwari Hall and Acharya Hall as per the schedule. Enjoy your break and thank you for being part of this vibrant beginning.
a highlight of ICRM, where distinguished speakers share their insights, experiences, and vision for the future. We have 4 eminent speakers lined up, each bringing a unique perspective to the theme of this conference. Each keynote address is allotted 30 minutes. To help our speakers manage their time, a gentle bell will be rung at the 25-minute mark. This will serve as a cue to begin wrapping up, with 5 minutes remaining to conclude the presentation. We kindly request all speakers to adhere strictly to the time limit so that we may honor the schedule and ensure every voice is heard with equal respect.
Our first keynote speaker is Sri Bharti Raj Balasubramanian, Country Head, Lions Boat India Private Limited, Chennai, India. Mr. Bharti Raj began his career as a software engineer with MetLife in USA. He later relocated to Singapore, working with Citibank and then Tata Consultancy Services (EPAC), where he advanced into senior management through his leadership and problem-solving skills. Mr. Bharti relocated to India after a decade to join in Lions Boat as the first country head of India, where he plays an integral role in the company's expansion plans by tapping on India's vast robotics and technology talent pool. He is committed to using his skills and experience to drive positive change while contributing to the growth and development of future technology within communities. Apart from his professional expertise, Mr. Bharati is also passionate about giving back to the community. Beyond corporate leadership, Mr. Bharati is passionate about AI, robotics, and workforce development. He actively collaborates with academic institutions to promote skill development in emerging technologies, bridging the gap between education and industry needs. His vision aligns with empowering young minds to leverage AI and robotics for sustainable solutions for future world. We are honored to invite Mr. Bharti Raj Balasubramanian to deliver the keynote address. We'll have first a video presentation.
So good morning, everyone. Can you play the video of Landsbot robots? Yeah, thank you for watching this video. So this is one of our product, the service, which is completely relevant to the service. Yeah, can you go to my slide? Sorry. last one. Yeah, thank you. Let's move to the second. Yes. So no, I'd like to address being we are into the service robots. I would like to cover the service robot industry and their future. Okay.
Namaskar, sir. Just a second. Slide changer is there in this.
Okay.
Okay.
Thank you.
Yeah.
So if you see the service robots, right? I mean the service. Probably we would have seen a lot of robots, predominantly in the industry, the industry automation with arms and different robots. But being implementing the robots into the service, it's more challenge than the industry. Okay, so if you categorize the service robot, you can categorize into three sides. One is for a professional service, it's like healthcare, logistics, or agri or public safety, like security. And if you come to the another category, the personal service robots, like what we are doing, like cleaning or companionship or elder care. And third one is the commercial service robots. It's like a hospitality or retail or customer service. So this is the major three industry where we can deploy the service robots. And let me touch the history of robots. Okay, so right now we start deploying the service robots. So how the industry evolved. In 1996 there was a first robo. Invented by Honda, where there is the human skeleton with the 2 legs, 2 hands, only with one sensor and one 2D camera. So that was the first robo invented by Honda. So that's triggered a lot of Hollywood robotic movies. And later there was a commercial emergence in 2000 and 2010. There I bought Rombo where you can see the domestic cleaning robots, which you would have seen even now for a lot of home users. That was introduced on 2002. And there were another parotherapy, like it's a small dog which is been introduced for a elder companion. That is also coming with one sensor and one 2D camera, but with a different use cases. And there is a third phase, the industry moved to the acceleration phase. Okay, that's where the AI integration and emotional interaction, a lot of disaster recognition, a lot of things come into the picture. That's been, the South Bank is invested a lot of money to make this happen. And right now we are into the different marketing market dynamics, and we would have heard a lot of revolution and evolution in the robotic industry, including you would have heard the Optimus from Tesla, right? So everybody is expecting the Optimus humanoid robot in the market by 2027. So this is where we are in the we are in the current world. So robots is already become a robots as a service, right? And even now we are doing our if you see all of you seen our robots, right? So already we start giving the robots as a service. So the industry already start moving to the robots for a service. So what is the market size for the service robots? So most of you here is going to complete your final year, right? So this data may help you if you want to be an entrepreneur, or if you want to be a part of startup company. So the global service, the service robots start picking up only last 3 years. So, but the industry is growing up a lot. So right now the global market value is 36 billion, whereas we are expecting this to be doubled in next year. So in 2034, it will become 166 billion. So what are the growth driver for a service robots? The first one, the labor shortage and rising wages, what it means. again, I pick my own industry. I mean, we are into the cleaning and commercial cleaning side, right? So, for example, in Singapore, the current average age for the cleaning labors is 63 or 64. So, what does that mean? After 4 years, 5 years, there will be no labors for a cleaning. But Singapore is named for a cleaning. I mean, clean country, right? Not just Singapore. This is happening both in Europe, US. But in India, it's different. Still, we are having lot of labors. But there, I mean, as soon as India also become more educated, lot of people start stopping to engage this kind of job. So this is where the robots coming into the picture to keep the country clean, the building clean, and street clean, right? So the labor shortage and the wages, like in US or Europe, the complaints for the labors or the labor's law is very strict, and their wages are very high. Okay, this is and in US right now, the current market, the cleaner salary is like 3,500 USD to 4,500 USD per month. So all this has become a challenge for a company or anyone. So all the people are start looking for an alternate solution with the service robots. And the aging population and elder care needs is another major industry, because even Australian government is keep talking to us, because they already start facing to take care of their elder population also in Japan. So and they keep they are okay to invest any whatever the amount we are looking for to have the solution what they are exactly looking for, a companion of elder and to take care of their basic needs like giving a short bath, taking them to a restroom, giving the medicine on time, kind of, because there were no people to take care of them. So we I mean the developed country already reaching to a certain side where there is no human support to take care of the elder people. And the e-commerce and last mile delivery, all of you are aware. So already Amazon start implementing the drone delivery, right? So this is the best example. And hygiene and safety post-COVID, of course, all of us are aware. I mean, Lionsbot in Singapore, we also introduced one robo during the COVID time to take care of the infected patients, to deliver the medicine, to deliver their food through a tray by autonomous system. And what is another important growth driver? The government and institutional support. And for example, in Lionsbot itself, the Singapore holding like 30%. Singapore government itself holding certain amount of share because they really want the solution to keep the country clean. So not only Singapore, even in India, they are okay to give grant in lot of technology solution. Okay. So what technology trends supporting the service robots, right? So there's another one, right? So the previous slide, what I have shown you, the growth drivers in the society side, what technology trend is supporting the service robot industry for that growth. First one is the AI-powered autonomy, which is really helping the deep planning for navigation and decision making and human interaction. So I hope all of you aware what I'm talking here. So AI is really evolved and everybody is talking about AI now. But AI into autonomy is something different, where you will actually feel the AI, where you will see the machine taking the real-time decision based on the collective input from the sensor, cameras. So those are the eye and ears for robots, including infrared, laser, many components, okay? And edge computing, this is another fantastic evaluation in the technology. Probably edge computing is one of the best example for edge computing is our phone, where it store all the data inside, it take a real-time decision for some time, right? So the robots also need to take a real-time decision in milliseconds, right? So
mostly we don't store data into the cloud. We store data inside the robots itself. So it take a real-time decision. Let's say, for example, it see any object, it has to take an immediate decision like a human. So it has to take a left or right, it has to go straight, it has to stop. Like human, it has to take a decision in a fraction of a second. That's happening only through edge computing. So next one's sensor fusion. This is the art and science of whole robotic. So the sensor fusion is like processing the collective data which we are collecting from LiDAR, ultrasonic, infrared vision, and mapping and object detection. Means the LiDAR will help us to do the deep deep vision of the complete building, whereas ultrasonic will help us to define the distance, whereas infrared will help us to study the atmosphere and the weather of that particular building. And this mapping and object detection is done by the cameras. So collecting all this input, the robots will, all these devices is like, as I said, it's like ears, eyes, brain, okay? The next important, the technology is the human-robot interaction. Probably you would have seen a lot of customer service robots where it's been already deployed in malls or some airports where you wave the hand, it will say hi. Where you say hello, it will say hello. Even some robots, by seeing your face, it will recognize whether you are upset. It will start the conversation. It seems you are upset. How can I help you? You can see in the Singapore airport this kind of device. So how this happening is all this happening with the technology, with the natural language support, gesture recognitions, and emotional AI. Okay, so there are a lot of tools, technologies available to take care of this. So earlier it's kind of mapping. Okay, it's a predefined mapping, like it will read the frame by frame and it will match with the predefined mapping, then it will respond you back. It's either a delay or it will not have a much user experience, but it's technology. With the current technology, it's all possible with the real time. And the next one, the modular hardware platform. What it means, so any robots, right, the skeleton is more important, okay? Probably you would have seen again the LineSpot robots, right? It have like 3D LiDAR, it have sensor, camera, it have its own AI autonomous system. Now we are deploying this only for cleaning on the big commercial property like mall, airport, warehouses, a supermarket, hospital. But the same robots can be replaced for a security service as well. How? We have to develop another software to take care of the local complaints, country complaints, and we have to append the one more 3D LiDAR. And with the simple changes, the same cleaning robots can be deployed as a security robots also. And also the same robot can be a warehouse delivery robots if I attach certain arm. So this is what I'm talking about, the modular hardware platform, swappable, scalable design. So this is how the industry is evolving, the same type skeleton you can deploy for a different purpose. And the cloud robotics and fleet management. So it's like probably I will show how are we managing this in the LineSpot. It means instead of keeping every service robot as an individual, it's important to manage multiple robots under the same environment. Means one robot is like a one brain cell. Combining all the robots is building like a brain. Okay, so I will explain in the next slide. So how the tech evolution is supporting the service robots. So as I said, AI-powered autonomy is now the autonomy tools. There are so many softwares available now. So it's really evolved well. Even we are expecting more evaluation will happen in next couple of years because of this new AI trend that's really replacing the scripted behavior. Like we don't need to script. As I said, there is no need to predefine. There is no need to mapping. Okay, if I wave hand, you wave hand. No, everything is happening real time. It's all about the machine learning. It's all about the data feeding. It's all about the testing with a different episode as one time. Later, the autonomy, AI autonomy itself study the human behaviors, different human behaviors. It start responding its own. And the simulation platform, it means like a digital twin system. I hope, I mean, even I seen the robo exhibition, the digital twin system developed by Professor Rajesh sir. What mean by digital twin? Like even NVIDIA have its own platform, ISAMAC. Many platform, even Simon had have its own platform. What it actually do means you don't need to develop a prototype. I mean, if you want to develop a prototype to test one actual service robots, you have to invest a lot of money and time for a design, and you have to procure certain component, including sensor, camera, everything is costly, right? So all we need to invest certain money to create a prototype, then we start validating with the prototype whether the actual design is working or not. But with this digital twin system, you no longer need any prototype. So all we need to do a design with the exact configure of sensor camera, where you can simulate and see all the validation performance before you go to an actual prototype. So that's another fantastic. I mean, a lot of platforms start coming. The best I can say is NVIDIA, and the generative AI is another tech evolution. It's enhancing the home human robot interaction, and yeah, this is where the Tesla Optimus is coming. So the Tesla Optimus is predominantly is they are building the technology using the generative AI to make the Optimus is more like a human, okay? But they haven't revealed much. We are also doing one humanoid robots. It's an R&D. So even we are excited to see how the Optimus output is going to be. So what exactly we are doing, what exactly the Landsbot doing part of the service robo industry. Right now we are in top 3, I mean into the service robot sector in the globe. So still we are investing a lot of money. Specialization in cleaning. Right now we are focusing the floor cleaning like carpet, marble, different floors. But right now we are more focusing on the big building, right? So still we do see even in Singapore, I mean you would have seen a lot of very tall building with 100 floors, etc., right? Still the humans are going and cleaning all the 100 floors outside the glass, everything. So now we are start focusing to take care of the tall building cleaning, and also we are focusing the domestic cleaning also, like for example toilet. I mean, if you go to the restroom, there will be a different type of toilet. It's a very big challenge to to clean the toilet in all the angle with the different variations, right? So we are investing a lot of money. There is a lot of R&D is going on to take care of different type of cleaning, to save the labors and also to address the shortage of labor to take care of this kind of jobs in future. And also, as I said, AI and perception leadership, we are also doing a lot of R&D into the humanoid robo. Our intention to 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 give the humanoid robot to give a best company for elderly people. So even in Singapore, I mean, not that in India, but if you see in Singapore, Japan, Australia, even in Europe, most of the elder, even in US, most of the elders stay alone. Okay, so I mean, I don't want to just touch that topic, but based on the study, we very much interested to release a robot to take care of the elder generation. And yeah, the global expansion strategy to make more service robots. We are also planning. Already we established, we expanded like US, Europe, even in Chennai since last 2 years. So further we plan to expand more to deploy more service robots across the globe. And yeah, so this is also okay. Yeah, so whatever I did, I mean, whatever I explained so far, right? Edge computing, fleet management, etc. This is the whole Lionsbot ecosystem. So if you see the Lionsbot have a different robots. I mean, each robot support a different atmosphere of cleaning. So, but everything is connected to a Lionsbot cloud. This is called the fleet management. Each individual robot is controlled by the mobile app, and the multiple robots also can be connected to the app, but which this will be monitored and handled by the cloud. This cloud will have a different dashboard. It's a fleet management where using this dashboard will have a big command center. So already we deployed 5,000 plus robots across the world, like 40 countries already. So all these robots will be monitored in the single room. So we will have a full control. Any issues happening in any of the robo. I mean, 5,000. It may be a 20,000. In future it may be a 1 lakh also. But all the control will be monitored from this fleet management system called Lionsbot dashboard. Yeah. So this is the. So what are how I mean these are the different service robot, I mean cleaning service robots, which we already deployed and are already available in the market. So if you see that big one, it's called Rex, that will cover almost 5,000 square meter. I can say, or it will cover 2 sizes of football court in a single run. It will cover the whole field in 1 hour. So, but there is no human needed. In all our robo, what is the exact feature? Like, you can schedule you can schedule a cleaning time like morning 6 a.m. Yeah, I mean evening 8 p.m. That's your job. So one time job. What the robot do? It will just wake up the scheduled time. It will go and take care of complete cleaning, and it will go back to the charging station. And this is the big one. And the smaller one, we have like R3 Scrub Pro and R3 Vac. One is for marble hard floors. It's called Vac. Another one is for scrub, which will be sorry, Vac for carpet floor, scrub for hard floors. What it will do, for example, in hotel you have multi floors, right? So same like as soon as you schedule the cleaning time, it will wake up on time. It will take care of its job. It will back. It will just clean the dirty water. It will refill the cleaning water for the next cleaning. If it is a multi-floor, it will connect to the lift. It will go to the first floor. It will go to the second floor. It will go to the third floor till it cover. And if the battery is drained, it will back automatically to the charging station. Again, it will resume its job where it left. So it will ensure it's covered the complete building. And last week we rolled out another interesting AI feature, again to avoid the human engagement. So we connected to the digital cameras. So wherever any other than the scheduled time, if any dirty happen across the floor where it is notified from the CCTV, our robots will go and clean and back. So still, you know, we are trying to implement more feature to avoid the complete human engagement. And it's not just a cleaning, it can be applied in any service robots. Okay. So yeah, thank you. I hope you understand what is that real service robots is. And these service robots, as I mentioned, there is different vertical, not just cleaning, customer service, hospitality. There were so much places where we are going to face human shortage, where no people will interested to do this job. So this is where we have to start thinking the solution for a future. Okay, so I hope all you students, with the help of Professor Rajesh and his knowledge, all you guys, all you people can learn a lot and try to implement some good solution for a future. Thank you.
Thank you, Mr. Bharati Raj Balasubramanian, for that enlightening presentation. We are open for questions now. Audience, please, if you have any questions. Student volunteers are already there with the mic. If you have, please raise your hand.
Yes. Yeah. So yeah, right now we are doing the mapping with the manual mapping, but we are going to release another version where the robots is sold to do the auto mapping with a 3D depth camera. So the R&D is on. So very soon we will release this auto self deployment, including mapping. Yeah. Next. Yes. Sorry, come again.
Actually, you were saying about the research team is going to do the mapping as a
Yes.
next task. So we do have many mapping methods. So what they are planning, are they starting with the occupancy grid mapping or
Yes.
slam type? You know the slam type.
Yes, yes. So
yeah.
actually, we are exploring the solution with a slam type. Only the challenge what we are facing the dynamic furnitures, like that's
Yeah, yeah.
where the challenge is coming. So, but still our team is keep trying with the different validation to to have the stable solution. But to address your question, we are trying with the slam mapping. Yeah.
Yeah. As you were saying, the dynamic objects is a prominent thing. Why? Because things change.
Yes.
The
Yes.
humans
Yes.
place in and around always change it. Static walls, maybe they are.
Yeah,
constant.
we have no challenge to address the static property inside the building. Only the challenge with the movable properties.
Yeah, okay.
So that is where the challenge is coming. So we have our team is trying to address to solve the problem.
Okay, so are they linking this to the self-driving autonomous vehicles?
Yes. Actually, what our intention is, this is a really challenge for us to. It is one of the challenge for further scaling. So if you see our robots, right, we have to have one technician to take care of the deployment in any of the big building. He has to take care of the mapping to solve. I mean, this is also additional expense, right? So what exactly our vision is to unbox and run like a TV. So we just deliver, the customer just unbox and just switch on the robot. That will take care of the self-mapping, self-driven, everything. So that's what our vision. I mean, we hope we will release this another version by 2026 June. Yeah, this is our target. Yeah.
Okay. Thank you, sir.
Yeah, thank you. Any question? Yes.
About this AI and robotics and the implementation of AI and robotics. In our Indian socio-economic conditions, people say about people will lose jobs, especially in the service robots. What is your experience by delivering this much 5,000 robots in the service sector?
Yeah, actually, we never market our product that we are replacing labors. We are supporting labors. Okay, so this is our one of the tagline. what it means, like as you said, even in Singapore, when we deploy this machine, the elder people will come and ask us, am I going to lose my job? So what they are doing, if you see, most of the cleaners engage only to clean the floor every day. So what we are doing, the machine will take care of the job. They will take care of cleaning like windows, glass windows. If you see, every monthly once only, the cleaners will take care of cleaning the windows, tables, everything, right? So the administration team start thinking how they can engage the laborers for other things where the machine cannot do. So actually we are not, to address this problem, we never say that we are replacing laborers. We are supporting the laborers. Yeah.
Actually, I asked this question to educate the public.
No, I completely
Okay.
understand. Even when actually we are talking to Tamil Nadu government as well to deploy this machine from secretary everywhere. So this is the same question because there was so many unions there. This is one of the challenge, but yes, but definitely this is not going to replace the laborers. This will support the laborers, one. And second, even though we are deploying the machine, still we may need a labor where machine cannot touch certain property, right? Yeah.
Second thing is, uh, 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 in a robot, there are two layers. That is the system integration level as well as there are subsystems.
Yes.
In the system integration as well as subsystems, how much level you achieved in indigenization or localization of technologies?
Okay. Maybe can you repeat your question? Let me understand your question.
Most of these robot building companies concentrate on the system integration only because they import the subsystems, assemble it, write code, configure it, and deliver it. This is the main methodology that followed by most of the robot manufacturing companies. So in the subsystem level also, how far you penetrated into the localization or indigenization of technologies?
Okay, so what exactly we are doing to address your thing, right? So our R&D, our manufacturing, everything is happening in Singapore. So what exactly we are doing in-house? We are taking care of the designing the complete product. Designing is happening, including the electrical, electronic, wiring, what kind of IPC we need, what kind of sensor, everything is happening, including the software, AI. All the designing is happening in-house. And 90% we are outsourcing for the component procure. Means we design, we deliver the file in a soft format. We do have our own suppliers, like we are engaging like 390 suppliers across the world. We are procuring not just only from China, Italy, in different places, even from Coimbatore. And most of the procuring is happening outside only, including batteries. So, everything by our supplier will deliver everything to our factory. So only we are taking care of the assembly. Then we are delivering the robots all over the world with a tag of made in Singapore. Yeah.
Availability of subsystems, which subsystem you feel most difficult to get or procure in the supply chain?
IPC. So IPC is the brain for your robot, right? So even we have faced, during the validation, you cannot really tell which slot of IPC will support on the durability. Okay, you can check part of the validation. You can come for a conclusion on the durability and reliability, all other component including battery, except IPC, because IPC is completely rely on the most of the semiconductor chips. It's complete build with a different component where you cannot see, right? So during the validation, we just, as soon as everything is work fine, we start deploying the machines. So what happened, one of the recent procurement on the particular slot, the IPC is very costly. We procured like 100 pieces of IPC. We deployed almost the 100 robots delivered to a different 100 different property. Exactly after 6 months, the IPC failed. across all the 100 robots. So what we came for a conclusion that particular production of that particular IPC got some problem. So it has some durability issue inside the chip that got failed. So this, so to address your question, IPC is a very critical component where you don't have a control to test that IPC is qualified or not. You have to completely rely on the supplier. Yeah. So any questions? Yeah.
Sir, what is the approximate life of your robots, and does your company support EPR, extended product responsibility, as it is an Singaporean based company? They are more into like sustainable things. Therefore, e-waste is a major cost for them. How do they tackle it, sir?
Okay. So what's your name?
Dashwant, sir.
Dashwant. Okay, Dashwant. So to address your question, I mean you asked multiple questions. So to address your first question, we are giving 5-year warranty. Okay. So how are we giving 5-year warranty? That's the question. So that's what I told during the validation. We have the warranty is always go based on the hardware component. The software you can control anywhere else. There's no need to be a guarantee or warranty. So hardware, how are we deciding this 5-year warranty is based on the durability testing. So we have to consider apart from the consumable. I mean, when I say it's a consumable always need to be replaced, right? For example, in your two-wheeler, there are certain things need to be replaced like tires. Nobody will give the warranty, right? So consumable is always a consumable. So other than this, like IPC, battery, I mean the camera, 3D LiDAR. So we go for, we do have our own framework to come for a conclusion how much warranty we can commit to the customer. That all depend on the durability test during the validation. Only considering the high value components, right? So I mean there is some component which may not long more than a year, but the value is very small, right? Few cents that we give anytime during the service. And how are we take care of the service? In that's a part of this expansion. We opened office in Chennai in Title Park just to take care of the 24/7 service. So post sales, as I said, I mean I hope you remember the dashboard, right? So we will have a 84-inch TV, like 5 TVs. So we do have a dedicated engineering team. Keep monitor the robots, what is being reported through by our customer, right? So we do have omni-channel. I mean, you also noticed our LineSpot app, right? This is the omni-channel app where the customer can connect to a LineSpot for any in sales, complaint, doubts, clarification, everything they can connect to the LineSpot through the app. Even they have issue, they will raise the complaint against the robot. Our team will start monitoring the robot. They start fixing the issue through a remote. 98% of the problem can be solved through a remote, but 2% some hardware failure, sometime our technician may need to visit their site to fix the problem. Did I address your question?
What will happen to the robot after its life, sir? Like disposal and stuff. Does the company
Yeah.
take it back?
So this is where, I mean, there's another challenge if you want to it's not just a robotic, any hardware company have this challenge. You have to have kind of complaint certificate. Now the sustainability is coming to picture. That if you want to market your product in Europe, right, they are very cautious on this sustainability and environment. There are certain companies like EcoVadis. You have to procure few certificates like EcoVadis, EPD, that you have, I mean, you have to gone through a lot of process to get their certificate and ranking. Once you get published, you can engage the vendors who will take care of your electronic product. There are some authorized vendors in the different country. who have the certificate authorized by government. So you have to have a tie-up with them. So after 5 years, it's up to the customer to deal with them. Okay. Yeah. Any questions? Yeah, I think we have 15 minutes more, right? Okay, thank you guys. All the best. Good luck. Okay. Probably you can find me in LinkedIn. If you have any doubts, any support, just say hi to me. Okay. Thank you.
Now we invite Mr. Rahul Lalpi, Assistant Professor, Department of Electronics and Communication Engineering, to present Mr. Bharati Raj Balasubramanian with a token of appreciation.
Our next keynote speaker is Mr. Amal S., Scientist F, Associate Director, Power Electronics Group, CDAC, Thiruvananthapuram. Mr. Amal S. is a Scientist and Associate Director at the Center for Development of Advanced Computing, CDAC, Thiruvananthapuram, with nearly 2 decades of experience in advanced system development in robotics, mechatronics, and electric mobility. Since joining CDAC in 2005, he has led the design and developments of micro-electric vehicles, tele-operated and autonomous ground vehicles, industrial automation systems, multi-dimensional simulators, charging infrastructure for electric and hybrid vehicles, and vehicle-to-grid technologies. His areas of expertise include real-time simulation, control strategy, and ECU development for xEV and autonomous micro-EVs, embedded systems for automation and mechatronics, and implementation of standards and protocols for EV charging infrastructure. He holds a BTech in Electronics and Instrumentation Engineering from the Cochin University of Science and Technology and an MTech in Automotive Electronics from BITS Pilani. Mr. Amal has presented several papers at IEEE International Conferences and holds copyrights related to EV charging system software and EV simulators. We are honored to invite Mr. Amal S. to deliver the keynote address.
Respected speakers and my dear brothers and sisters of Amrita. Good morning, everyone. Can you show that slide? Okay. Thank you for that. Thank you for that introduction. Actually, as a part of protocol, I need to say something about my organization. Actually, I think it is most required because most of you may think that CDAC people are supercomputing people who are working more on computers and softwares. Actually, CDAC is a premier R&D organization which is located around 12 locations and around 3,000 employees are working on CDAC. And we are working on all these sectors like power electronics, hardware design, strategic electronics, cyber forensics, and healthcare technology. So we are working not on the software but on hardware as well. And we are working on some national mission activities like National Mission for Power Electronics Technology and development of technology for electric vehicle subsystems. CDAC Trivandrum is the nodal center for these activities, and if time permits, I will say some details about these mission activities. So coming to our topic, mechatronics and robotics challenges and opportunities. We can see that mechatronics is a combination of all four engineering subjects like mechanical, computer science, electronics, and electrical. So mechatronics is actually a superset of robotics, where now in recent years some more technologies or engineering fields has come into this mechatronics field, like the AI, then IoT, then virtual reality, then machine learning. So by combining these, we can call these subjects some cyber subjects. So combining this mechatronics with this cyber subject, we can call this as cyber physical system. And as a nation, we believe that this funding more on these cyber physical systems and concentrating more on the R&D of these cyber physical systems will support the progress of our nation. So in the global scenario, we know that China, USA, and Japan are the three countries which are ranking top in the usage of robots. And among that, I think China is in first place, and each and every nation has their own thrust areas in robotics. Like it may be in manufacturing, healthcare, agriculture, then mining, depending on the industries available in their country. It may be mining, then national security is also a topic where we can apply this robotics. Similar to other nations, India has also identified 4 major thrust areas for robotics. Our ministry, that is Ministry of Information Technology and Electronics, has identified 4 major sectors in the National Mission for Robotics, or otherwise it is called National Strategy of Robotics. There, the 4 major thrust areas are agriculture, then manufacturing, healthcare, and the national security. So, speaking about the application of robots in agriculture robotics, actually around 20% of our GDP is coming from agriculture sector, and investing more on agriculture in this agriculture robotics will aid the progress of this sector. So in agriculture, we can apply robotics in various fields, like from seeding up to harvesting. In agriculture sector, farmers actually use most machines nowadays use machines like brush cutter, tractors, everything, which are causing more vibration, mechanical vibrations, and environmental pollutions. So this also these farmers are directly manually using pesticides and all. So these are the challenges that exist in agriculture, and we can utilize these challenges as opportunities. So yeah, we can use robots in pesticide management, then harvesting, weed management, seeding, etc. In the manufacturing side, actually around 3% of growth is found in manufacturing sector in India. And by the application of robotics in manufacturing sector, we can increase that growth of manufacturing sector. So in manufacturing sector, robots are commonly used in logistics, then warehouse management, then welding, painting applications in e-mobility or vehicle manufacturing sector. So in these sectors also we can apply robot. But the main challenge while developing robots in India is the absence of standards. Whenever we develop technology for a nation, we need to develop standards which is matching with our climatic conditions. Otherwise, we cannot predict or we cannot ensure the performance of robots in a particular area. So this is one of the main challenge that the robotic manufacturers are facing. That is, the only best standard available is IS 14662, but it is there is only limited data in that standard, and that need to be evolved. So in healthcare, actually this healthcare is considered as a social service by all nations, and we as a nation, India is utilizing around 20% of the economy for these healthcare services. And by implementing robotics, we can provide more service in the healthcare and reduce the utilize efficiently the funds utilized in healthcare sector. So in healthcare, actually after the COVID-19, there is more importance to the hygiene and all. So this is an opportunity to robotics, so that the places where need more hygiene, we can use robots. Also, for surgical assistance, robots can be used. Then rehabilitation robots can be used, and teleoperated robots. But the main challenge in using robots in healthcare is it needs a good infrastructure in the case of energy as well as connectivity. Suppose one critical surgery is going on and the power failure, what happens? Also, if the connectivity loss is there. So good infrastructure is required for implementing these teleoperated surgical robotics in healthcare. So we can use robotics in some other sectors as well, in national security and in space applications. In national security, drones and other unmanned vehicles can be used for surveillance, bomb detection, and other such purposes. In space robotics, for planetary exploration and all, we are now using robots. So in construction and mining also, there are applications of robots. So if we analyze a robot, which are the three main components of a robot that we know? There is a brain, equivalent is the controller. Then there are some sensors like eye, ears. There are camera, lidar, etc. And as actuator or muscles, there may be relays, drives for these devices are there. So simply we can say robotics is a combination of mainly of these three components. So commonly in the computing platforms, as said earlier, we are facing difficulty in procuring these computing platforms. We are mainly now relying on the computing platforms such as Jetson Nano from NVIDIA, or the Raspberry Pi, or ARM-based microcontrollers. So we are depending more on foreign countries or foreign technologies in this area, and we need some indigenization in this part. The other sensors used in robotics are the lidar, IMUs, ultrasound sensors, stereo cameras. In this level also, we need the development of technologies. And in the other technologies that enable robotics are the communication development requirement, like CANs, SPI, Ethernet protocols, and the development of drivers like motors, PMSM motors, BLDC, and other actuators. So robotics is actually a multidisciplinary subject, and it is actually a continuing debate that whether we need a undergraduate program for robotics or not. How many of you think that we need undergraduate program for robotics? Okay, but my personal opinion is different. The reason is actually robotics is not a one-man show. A single person cannot become a robotics engineer. Actually, it requires the expertization from each and every subject. That is, we need a mechanical expert, we need electronics expert, we need computer engineer expert. So the combination, each and every expert can have their own role, and they need to work together. And it is the beauty of robotics that by working together, they can create very good products. So my opinion is concentrate more on the basic subjects and work together. And you can specialize on robotics. Okay, this is my opinion. Okay. So what are the main challenges that we face today in the development of robotics? First one is the inadequate skilled human resource. So actually recently we did one recruitment for the development of hardware hardware electronics that is required in these type of projects, and there were 50 vacancies in that recruitment, and we got only 4 number of engineers, talented engineers. This is the main issue that we face today. Can you believe that? But actually I don't know where is the gap exist, because most of you say that there is unemployment in our nation, but at the same time when we call for experts, there are no experts. This is the issue we are facing today. I am not sure whether these people are going abroad, I am not sure, or whether there are no talent in India. That we need to analyze. That is the one major issue. Next thing is heavy reliance on imports. In the present geopolitical situations, we know that our present friends may not be friends in future. So we know that in robotics, what we have seen is most of the robotics manufacturing companies, there are 2 levels, as I said earlier. One is a system integration level, and there is subsystem development level. Most of these robotics manufacturing companies are concentrating on the system integration only. That means they import all these components like sensors, processors, and actuators, assemble it together, wire it together, and we have good software engineers to configure the software, and they develop very good. They are very intelligent people. Actually, they are experts in developing software, and they produce the product. But the main challenge in this methodology is, as I said earlier, our present friends may not be friends in future, and we will go to danger in future. So we need to develop the subsystems as well. And as a R&D organization, we have some responsibility, and now we are concentrating more on the subsystem level development and not on the system integration. So which are these subsystems that exist in a robot? That is the microcontrollers, sensors, energy storage, actuators, and software. So at the microcontroller level, we have started manufacturing or development of Indian chips. You can search Vega processors in net, and you can see microcontrollers developed in India, which can support from 8-bit to 64-bit microcontrollers. I admit that these processors can do only small level activities like sensing, object detection. Those small type of algorithms we can run now, and in future I am sure that we will develop to a system which can support all the AI algorithms. And in the sensor level, we have developed the sensors for underwater projects like ultrasound sensors. We have developed our own cameras, 3D cameras, and other IR cameras are also we have developed in the sensor level. In the energy storage, actually we don't have the cell level technology. We import cells, we assemble it, and we can develop BMS for that. In the BMS level, we have developed our own BMS. And in the actuator level, the main actuators are the motors or drives. There are different various types of motors and drives like a PMSM motor, BLDC, induction motor, SR motor. In all these technologies, we are capable of developing the controller for all motors. And in the software level, of course, we have a lot of experts in the software level. So other challenges are limited governance mechanisms. That means the certification or the standard availability in India are very less, and we need to formulate the standards for robotics. And there should be some certification mechanisms and there should be some qualification test centers available in India for robotics to ensure the performance and to benchmark it with the globally existing robots. Then the absence of multidisciplinary collaboration, that means there are a lot of R&D institutions in India which are working. One institution may be working on mechanical side, one may be in electronic side, one may be in computer science. And there should be some mechanism to coordinate all these R&D institutes because robotics is a multidisciplinary subject. And other challenges include the educating public, they are actually concerned about the job loss and all when we implement AI and robotics. In this side also, there are challenges in Indian conditions. So make the concept simple. I will show you one complicated diagram of electric vehicle. When we actually there is one analogy between the evolution of electric vehicles as well as robots. Earlier, during the implementation of electric vehicles, what we did is we imported the subsystems. The subsystems like battery. In the powertrain, we can see there are a lot of subsystems like mainly battery, the battery management system, then the drive, then the overall chassis and all. In the early stage of the evolution of electric vehicle, actually we imported all these subsystems and integrated it in India and developed our own electric vehicles for faster adoption of electric vehicle. But in second phase, what we are concentrating is the development of each and every component, that is each and every subsystem in India. So the same evolution will happen in robotics also. Now we are only in the first stage of robotics where we are importing the subsystems and integrating it. Next level, we need to move on to the development of subsystems. So these are some mechatronics projects in our portfolio. Actually, as an R&D institute, we are not producing any product. We only develop the technologies, transfer the technologies to other firms and support the technologies. So whenever we develop a technology, we develop these technologies are a development platform where they can make some changes, configure it. They can also contribute to the development and they can make their own products. For example, this is the first one. Is a teleoperated device. I am not sure whether we can call it a robot or not. Can anyone say a correct definition of robot? Anyone say a definition of robot? Is there any definition for robot? Okay, there is one answer. Any more answers? Okay, okay. Actually, I have heard lot of such answers. All these answers are correct. And the best answer I heard is like, I don't know the definition of robot, but I can say this is a robot when I see it. I think this is the one of the best definition because most of us have various definitions for robot. So I think what is a robot is, it is an intelligent machine which can achieve an assigned task. Okay, this is what I believe. So we can call this a robot or not. What the assigned task is, this is the first robot that we developed in 2004. I am not sure whether we can call it is as the first robot in India or not. I am not sure because it is only a teleoperated device which can go inside the Baba Atomic Research Center whether there was radiation and all. Human beings cannot go inside the nuclear power plant. So we used this device to go inside the nuclear power plant and take some samples from inside the power plant, make some surveillance and all. Can you predict what are the challenges in developing such a system? One major challenge is why humans cannot go inside a nuclear power plant. There may be radiation. So when we develop such systems for nuclear power plants, we cannot use normal electronic devices because there are programs inside microcontrollers programs will get corrupted by these radiations because there will be damage in the circuits and all. So how can you eliminate these difficulties? One solution is we use the red hardened components. Second thing is we use the lead to cover all these components. We use the lead boxes and coverages. Next thing is we routed the light through another path to go to the camera. We cannot directly expose camera into the radiation. Then it is CMOS will be affected. So I can say actually this robotics is not a pure science. It is like some art and science, so that we can apply any logic depending upon the environmental conditions. So next one is called a hazardous object removal system. The next thing, which also we developed as a development platform where we can attach many accessories. Here we attached one mine detection accessory, where it can go in all terrains and scan the mines in war areas and identify mines and mark it. This is the application of second thing. I will show you one video. Can you click on that video? Okay, otherwise after the presentation I will show the video. But I think video is not there in that folder, right? Okay, I will copy it and show it after the presentation. Okay, otherwise if you give me 2 minutes, I can copy it and show. Okay. Okay, after the presentation, I can show the video. So you can see a special type of wheels in that vehicle. Those are called skid wheels or rolling wheels. The peculiarity of those wheels is this vehicle is designed as a all-terrain vehicle which can go in floor as well as outside area. It can move through rocky areas, sand and all. And at that time, if we use this vehicle in normal floor conditions, it will create some markings. As you see here, this is a photo taken 2 weeks back when one robotic company was testing their robot at the CEDAC Technopark campus. I got this picture, and you can see wherever those vehicles go, they will keep their footprints there. So, but in this system, it will not make any footprints on the floor. Here's the peculiarity of that wheel. But now you may doubt that it will skid when it moves through slopes and all. That I will show the performance of it on the video. This is the control station of that vehicle, and this is that vehicle fitted with an arm which can handle the shells which can be loaded into the weapons of military. So this is a wheelchair that we developed. This is also developed as a development environment where there is interface which can take signal from any controlling sensors like brain signals or other signals. Only thing is it need to follow some protocol. There is a CAN protocol in this vehicle. By giving messages to the CAN protocol, we can control that vehicle using any.
Excuse me, sir. You have 5 more minutes to conclude.
Okay. Using any input device. These are other hybrid electric vehicles that we developed. We have also developed algorithms for omnidirectional robots which can move in any direction. So this is one unmanned ground vehicle, and this is one autonomous surface drone that we developed. It is mainly used for surveillance purposes. This is one underwater drone which can go up to 100-meter depth and do surveillance. So suppose you have some idea on robotics. Now you know the application areas, the challenges that exist in robot and all. Suppose you have some idea and from where you get fund. So we are running two main mission projects like National Mission for Power Electronics Technology, which mainly concentrate on the development of subsystems for power electronics as well as the power electronics devices. The next mission project is electric vehicle subsystem projects, where we fund for projects which are based on e-mobility. So actually we have three modes of operation. First one is we find out the technologies that are to be indigenized, and we develop the technology with our our team expertise, and we transfer the technology to multiple organizations. One of such technology that we developed is the vehicle control unit for locomotives, that is railways. How many of you know that our railways are moving with CDAC technology? Actually, the railways VCUs means the vehicle control units are were using ABB technology, imported ABB technology, and it was their monopoly. At that time, the railway approached us to develop the technology, and now we develop that technology and transfer the technology to multiple companies. Now there is no monopoly, and thus the price has reduced. There is the way we work on indigenization and localization. The same thing we can apply on all fields like e-mobility as well as robotics. The next mode of operation is if you have some requirement, like if any private company has some requirement, they can contribute in some way, like in-kind contribution or something. Partner with us, we can develop the technology and we can transfer the technology to you, but that technology will not be exclusive. We will transfer the technology to multiple organizations also. We can also take exclusive projects from other companies. So similar to these two mission activities, MIT has MIT, that is our parent, that is our ministry, has the National Robotics Mission, whether they are aiming for faster adoption of robots, and in future they will fund for such projects as well as for test centers and all. So we are actually partnering with all these institutions as well as academies. So if there is any development requirement, we can partner with all these academies and create a solution for that. So to conclude, robotics is a multidisciplinary subject, and robots application span on various sectors like industry, healthcare, etc. And there is the main main requirement of robotics is the indigenization of the technologies. And as an R&D institute, we can support you by providing technologies as well as financially. Thank you. If time permits, I can show that video.
Sure. Before that, thank you, Mr. MLS, for that enlightening presentation. So now audience, you are open to questions. If anybody has any doubts, please. Meanwhile, sir, can you give the video to the team?
Sir, CDAC has how many patents, and what will be the patent, if they are given to us for further development on it?
1 minute, sir. Sir, your question was about patents and
Yes,
application of
yes,
patents,
yes.
right? Means
Which areas you have the patents and which we can contribute, you can give it to our university so that we can work on it.
actually, I said earlier, we have many working groups like cyber forensics, power electronics group, hardware design group, and all. All these groups has their own patents in all these fields. In the robotics side, in the video, I can explain the patents existing. Okay.
So total patents we have is from CDAC?
Total number of patents, I am not sure about the number. Actually, we have patent on the mechanical systems inside robotics, like automatic hill assist for robots. Then the mechanical differential drive system for robots. Then in power electronics side, we have patents on the controllers for devices, like drives for motors, then the power conditioning units for power electronics.
Do you charge anything, sir, for us to work upon it?
There will be a small royalty for that. It will vary from some 2% to 3% royalty whenever you use that patent in your product. Actually, this was developed in 2008 only. So the technologies, the basic technologies like batteries used there are very old technology like lead acid battery and all. But the mechanical systems that exist in the system, you can check the performance of the system. You can see that it is not making any marks on the floor while rotating. This is called swirling motion. Actually, this swirling motion is very important when we operate robots in small constrained areas. We tested this in almost all terrains, in rocky areas, in sand, in high slopes, stair, and all. It can carry a payload up to 150 kg. Since now we are more concentrating on the development of subsystems, we have technologies for controllers for almost all type of motors. You can see that there is a hill assist system. Even if the complete electrical system fail, the system will not come back because there is a mechanical hill assist system in that. You know that there are two types of differential systems. There is a mechanical implementation and other one is a electronic differential. You know that in mechanical, the mechanical gears will implement the differential gear system, but in electronic system, two separate motors will be used at the left and right, and electronically we implement the differential mechanism. But the main challenge in implementing this electronic differential is to check the performance of such electronic differential system. Just put some obstacle in front of any one of the wheel, then the complete system may jerk. If it is not jerking, that electronic system is perfect. Otherwise, your algorithm is not perfect. The second phase, we developed the controlling mechanism for the arm and grippers and all. The gripper also, there is one challenge. That means these grippers are proposed to use to carry shells and all, handle shells and all. If it exert more pressure on the shell, it will explode. So there should be a controlling mechanism to take and control the force exerting on the shell mechanism. So these are some technologies you can also explore when you handle your objects. Okay.
So one more question. So you have shown the underwater robot. How are you handling the pressure in the underwater? Because as you go inside, the pressure increases.
Yeah, that is one good question. because that is the main challenge when we go below water. Because when we go below water, actually there is one underwater mission project of India which is called Matsya 6000, in which in 2026 we are aiming to go into the depth of 6,000 meters and explore the ocean. It is the first kind of the world. You know, the other project failed, which was of 5,000 meters. So similarly, India has a mission project. In that project, the main challenge is this thing. That is, how can we manage the pressure? So in managing the pressure, even from cabling to developing each and every subsystems, we need to take care, because even the cable, we need to use special type of cables. Like in normal cables, there will be air bubbles, small air bubbles, which we cannot notice. But when we go beneath water, the high pressure will crush these bubbles and the cables will break. So similarly, there are a lot of challenges. All these challenges are met by different methods, mechanisms. These cablings, they use special type of cables, which is specially designed for underwater operation. Similarly, each and every subsystem will be designed accordingly.
How are you doing lab test?
Doing lab test, we have our own controlled environment with water tanks and all, and we test it in dams also.
That means you have a pressure buildup labs?
No. Pressure buildup not there. We use in the existing dams and all only.
And so third thing is about the farmers. You know, you told many equipments you're developing for the farmers.
For farmers?
For the farmers, you're developing the equipments, no sir, for the fertilization, for the pesticides.
No, at present we are not making any. I only said the application for India.
So you're not making
agriculture.
anything.
No.
Okay.
Actually, we can use all these development platforms, like we have drones as well as UGVs, which can be applied to any sector. Only thing is we need to develop the matching end effectors or actuators for those things. But we have provided all interfaces for that. You can control. You can take control of the controller.
And the last thing which you have shown in the videos, the robot which you have developed, it has a flat surface, okay, and under which it has 3 wheels. If it has flexibility of the rather than the flat surface, if it is flexible, then we can climb the more, because right now I can see that 6 inches step it can actually either climb or either it can come down. If it has increased to 1 feet, 1 foot, then I see a challenge in your robot, whether it can climb it or not, or 2 feet steps are there.
Okay.
So if there's a
To manage the step climbing, actually we put one cam on that. Means there is a 60-degree cam on that. First, it will hit the stair, and it will aid in climbing the steps. If we know the exact size of dimension of the steps, we can design the cam accordingly. Also, regarding the flexibility and shock absorption, there is a shock absorber designed especially for that vehicle.
The flat surface which you have kept, if you can make it flexible,
Yes,
then it can
yes,
have
of course, of course. If you make the flat surface a split frame, then of course the area of contact can be increased.
Yes, yes.
We have such platforms, but they are of small types with omnidirection capability.
Okay, so thank you very much, sir.
Sir, does CDAC really focuses only on electronics semiconductors? Because I feel that future of electronics is not only semiconductors. Because I feel its recycling and sustainability is a question mark in it. Does it focus on photonics or organic semiconductors?
Okay. Actually, the recycling and sustainability, it is a major challenge and good opportunity to everyone because in electric vehicle as well as in robotics and mechatronic systems, the recycling of this electronic waste and all is a major challenge because how many of you have recycled your mobile phones properly? Most of you ask questions how you can recycle your system, but you are not even recycling your personal things properly, right? So the waste created by each and every mobile phone batteries is huge because most of you have smartphones now, and you will throw it in some scrap pad and it will create some issues that is happening. So it is a very relevant question because most of the time as an R&D institute or other companies, when we draw the V diagram, we start from the specification formulation, then simulation, then production and all, and we stop the V diagram in that part. We will not include the recycling process in this, even in that V diagram. So there are a lot of things we need to consider in the recycling. That is, even in designing a product, we need to put each and every module so that it should be modular, and we can take each module outside the system, and we need so that we can easily recycle it. So this is a major issue, and this is a major field we need to concentrate on. But the recycling of batteries and all mainly depends on the chemistries. So CDAC is mainly concentrating on the hardware side and software side and all. These things need to be taken by the laboratories and R&D centers, which are mainly concentrating on the chemistry and all.
Sir, like how about organic semiconductors? Other than using silicon and germanium, carbon-based polymers, does CDAC work on that, on R&D, to make subsystems?
To make things clear, actually, we are not manufacturing the exact physical device as such. Actually, the chip manufacturing itself is a major challenge. It depends on whether it is using silicon. In the power electronics side, actually, we are moving from normal silicon devices to GaN as well as silicon carbide. This is the major trend, so that we are using GaN and silicon carbide devices for most of our power electronic devices. That is one of our achievement when we go for the development of subsystems for electric vehicles and charging infrastructure. We are using this now we are using GaN and silicon carbide based devices. It has its own advantages, like we can reduce the size of the overall system and all. So we are only developing the controllers for these devices. We are yet to develop all these devices. It more depend on the chemistry and the material science.
So does India have a fab unit for it itself, like government sector?
Actually, the government has invested a lot on developing the fab units. It is in the development phase only. Actually, it has initiated the development of these fab units. Now, what we did is we developed the circuits and IP for the chip. We designed the chip, and we are manufacturing the chips at Thailand. Okay, thank you.
Thank you, sir, for the wonderful session. Now I request Dr. Vishwas S. Nair, Department of Electronics and Communication Engineering, to give a token of appreciation to Mr. Amalas.
Our next keynote speaker is Dr. B.S. Manoj, Chair, IEEE Kerala Section. Professor Dr. B.S. Manoj, Chair, IEEE Kerala Section, is currently serving as Senior Professor and Associate Dean at the Indian Institute of Space, Science and Technology, IIST Tirunelveli. He received the National Teachers Award 2025 from Honorable President of India, Srimati Draupadi Murmu. He is a board member of the Membership Services Board of IEEE Communication Society. Professor B.S. Manoj completed his PhD from IIT Madras in 2004. He was trained in information technology at the University of California, San Diego, California, USA, as a postdoctoral scholar from 2005 to 2008, where he subsequently worked as research scientist and lecturer. In 2011, he joined as associate professor at the Department of Avionics, Indian Institute of Space Science and Technology, IIST Trivandrum, India. He became a full professor in 2017 and served as head of Department of Avionics during 2016-19. He received many awards and honors, including IEEE Outstanding Researcher 2020 from IEEE Kerala Session, Teaching Innovator 2016 from MHRD, Government of India, the Outstanding Leadership Award by IEEE ICNC 2015, and the IBM Outstanding PhD Thesis Award 2004, to name a few. He developed the MHRD awarded multi-track modular teaching as an innovative method for research-oriented teaching, which is now being used by many autonomous institutions and universities for improving the employability of students. He has published more than 200 international publications, including journals and conferences, which totaling a citation of more than 7,200. He has authored or co-authored 3 books and 10 book chapters. He holds a research H-index of 33 and an ITIN index of 93. His current areas of research include 6G networks, AI/ML, Internet of Things, brain-computer interface, complex numbers, and cybersecurity. We are honored to invite Dr. B.S. Manoj to deliver the keynote address.
Thank you for inviting me. I know I'm standing between all of us and lunch, and I'll rather be very quick today. So my name is Manoj. I'm a professor with IIST. First couple of slides are about IIST. IIST is a university in Trivandrum established by Department of Space. We have 4 BTech programs, 16 MTech programs, PhD and postdoc programs. I'm with the Department of Avionics, where we do electrical engineering to computer science related studies, including research. So this part is actually covered. Now we also have one 5G use case lab provided by the Government of India, Department of Telecom. This research lab is having a full-fledged base station and associated resources for the students and faculty members, as well as other institutions to do research. This lab is opened up for students and faculty from Amrita also, so please feel free to use that. And today our main point is about robotics, and I want to just to touch upon the history very briefly. As you know, the pioneering invention by James Watt in the form of what is it called steam engine in 1769, that actually made the revolution that we today call Industrial Revolution 1.0. So massive machinery, including train, ship and other things were built during this time that we call as Industrial Revolution 1.0. And by the invention of electricity by Michael Faraday and the practice of Nikola Tesla and Thomas Edison, electricity has made a huge impact in human lives, where power generation, distribution and consumption by various types of appliances, which made human life advanced to a great extent. And the third industrial revolution happened in the 1900s, middle of 1900s and 1940s, exactly when electronics as well as innovation by transistor or invention of transistor by these three gentlemen, John Bardeen, William Shortley, and Walter Brattain, started in Bell Labs. So this invention, transistor, created a revolution unlike anything in the past, either Industrial Revolution 1 or 2, because we could actually amplify an electronic or electrical signal for various use, which including that of telecommunication. Now, the invention called electronics resulted in the computer development, and we are today in the middle of Industrial Revolution 4.0. And this 4.0, two of the important elements of Industrial Revolution 4.0 is robotics and cyber physical systems. We just now have heard from one industrial expert who is actually pioneering the robots, and another national R&D organization scientist, Amal, about cyber physical system and robotics. And these are actually driving the Industry 4.0 revolution in which we are in. And if you look at one aspect, when we invent new things in Industry Revolution 4.0, these inventions are actually reinventions, not new inventions. Instead, we actually reinvent many things over and over again with the availability of newer technologies. Just today morning, you have witnessed the HUD Lab developed coconut dehusker. Okay, so we have actually done 2 generations of dehusking machinery or tools before we actually come up with the AI-driven robotics machine that will do dehusking. So it's a 3rd generation equipment if you consider this as a revolution of human development. Now, robotics is everywhere, from industry to environment to transportation. Robotics have seriously influenced, and robotics is also playing a very significant role in the homes, including that of the major significance of the next generation, that is developing technologies for the kitchen that we have been using for generations. Now, very significant technological evolutions are going to come in the technologies that will suit for daily cooking, washing, and so on. That is actually going to be huge. In fact, we can speak about the possibilities, the endless possibilities of this particular smart home appliances in the application of robotics, similar to what we discuss in the industry applications. I'm not going to much details, but I just want to highlight a few points where robotics is actually extending the human reach or influencing other domains in a far more significant way that we earlier thought. One is that robotics influences the next generation of networking. So as you may have seen, the generations of cellular or wireless communication, say 1G, 2G, 3, as well as up to 5G. So these were all the growth influenced by the requirement for human communication, human to human communication, or human to internet kind of communications, and that kind of communications. But if you look at the most recent generation change, so 5G to 6G generation change, where the influence is actually by the robotics industry and the future requirements of the robotic industry. If you just Google the use cases identified for 6th generation networking, you will come across like automation, healthcare, autonomous vehicles, advanced AI integration, and low latency, and so on. Out of these 6 main use cases, actually 4 of them are directly influenced by the evolution of robotics. And for example, factory automation, motion control, autonomous vehicles, intelligent robots and cyborgs, motion control, and all the applications that are very significant, very latency sensitive, very bandwidth sensitive, are all influenced by the robotics industry. And if you look at specifically the KPIs, key performance indicators of 5G KPI is like frame error rate of 1 out of 10 power 5 frames, or other parameters that we are now using in our networks, versus that we are planning to develop as part of 6G networks. You can see there is tremendous enhancement. So while mobility is a second 2x times, two double increase from 500 kilometer per second to 1000 kilometer per hour, but all other factors like a 10x improvement in the latency from 1 millisecond to 100 microsecond, or 100x improvement in the reliability from 10 power minus 5 to 10 power minus 7, or even the traffic capacity and peak data rate, which is like 50x improvement in 6G networks. And if you look at whether it's a latency, which is critically demanded by the haptic services, haptic applications, or remote telesurgery applications, or if the throughput that is very much important, that's again a robotic application. Or if you are looking at the frame error rate, many of the robotic applications need very high reliability too. So most of these key performance indicators that we are planning to enhance into 6G networks are all influenced by the evolution expected in the robotics industry only. So this is one significant influence on the evolution of communication networks by the robotics industry or robotics future. Now the connected robo. So we in the traditional past we used to have robots which are autonomous and so on, but today we cannot imagine a robot without connectivity. You have seen the live demo of several of these robots, but all these robots are actually connected. So it becomes a dependency on the performance of the network that is actually define the robotic systems performance. So by 2030 the entire connected robotics market will be something like $160 billion worldwide. It's a huge impact where mechanical engineering to computer science engineers will be working hand in hand to utilize this market related thing. Now I just want to highlight another factor where today's satellite networks, today's satellite network is not unlike anything in the past. We have tens of thousands of satellites in the space circling around the earth, much like a highly compact mesh, where the satellites work much like a sophisticated robots, because these satellites are actually being like tens of thousands of satellites. They have to face collision like half a dozen times a day. Every day more than 6 satellite collisions are detected and avoided, and these are actually examples of autonomous devices in space, that too not in small number, like tens of thousands of devices. And these satellites provide another aspect of robotics, that is high data rate intercontinental communication. Intercontinental communication is actually 40% faster than the intercontinental optical fiber communications. Today if a doctor is actually going to operate a patient across continents through remote surgery, then that must have high latency, very low latency and high bandwidth, and satellite network is actually going to be providing that. Now this is a picture I have taken. I wanted to show a demo, but there is no time to show the demo, so I will skip that particular point. But you can take a view of the satellite constellations to see the magnitude of development of these autonomous devices located all around the earth at 500 to 600 kilometer altitude. Now, second point I want to mention is communication networks are seriously influenced by the robotics systems, and the patient care is actually going to be seriously influenced by the robotics influence. Now, extending the human reach in surgery. As you may have seen, this is a picture I have taken from Amrita Hospital to show the doctors operate on a patient for knee replacement or for hip replacement. These orthopedic surgeries can be more effectively done using robotic surgery than using manual approach. So the main advantage why people are going for that, enhanced precision in the operation, or less post-operative pain, faster recovery, and reduced hospital stay, and minimal scarring. In fact, patient satisfaction with robotic surgery seem to be about 30-40% better than manual operation surgery. So we are extending the human reach by the assistance of the robots that we have. This is a picture I have taken from the Da Vinci robotic systems page to indicate where actually the modern patient care is moving in terms of very complex surgeries. Now, I have already mentioned, in addition to the next generation networks, next generation surgery world, space research, underwater research. In fact, Amal sir has already mentioned about underwater research. You can't do underwater research today without using robotic surgery. Agricultural influence. You have seen the machine here. You may also see the Hut Labs, invention or R&D output for climbing and harvesting coconuts, which is actually a classic example of interdisciplinary research. And every factory, as you see, cannot be done today without robotic automation. Now, I want to take a few minutes about India-specific robotics and why India has to seriously look into. So I looked at this particular data in 2023, where we have matched the Chinese population. And 1 year later, we have reached like 1 crore people more than China. And in fact, when I did the last year prediction for this year, then I found that India has something like 40 million people more. That means 4 crore more people. Okay. But actually, this year when I verified this prediction, then I find that India has something like 5 crore people more than China as of today. So this 5 crore indicates pretty much more than Kerala's population. So 1.5 times Kerala more people are there in India than China. But if you look at 2030, 5 years from now, by the time many of the undergraduate students graduate out of here, so India will have something like 130 million, 13 crore people more than China. That is the collective sum of both Tamil Nadu's and Karnataka's population. So we are actually going to add in next 5 to 6 years entire South India more than China to do that. So so this is actually giving rise to very significant issues. While we are first in several of these things in terms of production of food, number of people, number of films produced, film industries. Second in mobile phone use, third or fourth in electricity. Sixth in robotics deployment in 2025. We are behind only 5 countries in robotic deployment, and this is actually very important development, unlike other opportunities that we have seen. But what we are seriously worrying about today is India's global innovation index in various topics, including R&D for robotics, is only 39. So this is actually a very alarming situation, because we cannot remain as a country on the top leading country with the innovation index so small, while on the other ranking we are very, very high. So in fact, far more alarming situation is that by 2050, about 1 out of 5 senior citizens of the world will be in India. And this is what in fact many of our speakers before mentioned about the home care, patient care will be very significant. I just want to say that the future possibility for Indian robotics industry is very bright. As you may see from the last 5 years, for 2020 to 2025, this is 2025 number. So we have about 300% growth of deployed robotics, industrial robotics. And right now the growth is something like 7% compared to other countries. We are 6th in the world in deployment. If you look at on an average 6 to 7% annual growth, so India's growth alone will be about $500 million business, where the services robots, as you have seen from the Leon Bot's presentation, services robots actually dominate the market about 3 or 4 times more than the industrial robots. We have to seriously invest in developing R&D for the industrial robotics, because industrial robotics actually help produce better, produce faster, produce more accurately, which is very essential for a country like India. Now, I also want to mention about a particular thing called India-specific robotics. India-specific robotics is actually not going to be developed by anybody else. So this is actually work done by in our institute, where patients who are unable to speak, when they want to drive a wheelchair or something, we can use BCI, brain computer interface to control the wheelchair. So they can think or they can subvocally speak, and the brain computer interface can actually detect the words and navigate the wheelchair. But the problem with the Indian situation is that 90% of the Indian people cannot speak English, where most of the existing BCS solutions are English based. So we set out to develop some of the data sets. So two of the data sets for Indian languages, like for Malayalam and for Telugu, we have developed the data sets that can be used to control the or design models for controlling the wheelchair have been developed, have been made available to the public. But there are so much more work that needs to be done for India specific robotics application in this patient care segment alone. So we need to work on that. So as I have already mentioned, so this is some pictures particularly from one of the very successful companies in the Indian segment, that is Gen Robotics. They have developed an India specific robotic system, Bandicoot. You all know that it is to remove manual scavenging, and they have developed a very complicated technology through their own internal R&D service. They actually dig dirt from the manholes, so therefore manual scavenging can be avoided. So you have already seen this in this institute, the Hut Labs product on harvesting coconuts. This is an example of India specific robotics. India's Vyomitra is actually the humanoid robot that we are trying to send it to space before the actual humans can fly. So this is actually a partially visible robotic arm ISRO has developed and test flown early this year for trying to remove the space debris from orbiting platforms so that we can clean up the space with this. So this developing robotics for the space is a altogether different design, because you don't have gravity there. In zero gravity, robots may behave in a very different way. Even if you develop that in the ground, but when you take it up to orbit, it may work in an unpredictable way. So you need to test these robotic arms in space. So ISRO provides a platform for universities to experiment with that. So this is one of the platforms experimented in space early this year by ISRO. So let me close here, and I just want to highlight the one particular point that we need to develop our India specific robotic applications, which is going to be very significant opportunity for all startups and industry and universities in the next 30-40 years. And the market is actually significantly exploding, and as a large country, we have to actually develop this for our country. Thank you so much for listening. If you are having any questions, feel free to ask. Yes.
Increase the more research.
So you are talking about IAST, right? IAST or IEEE?
IEEE and IAST collaborating, and we are having a combining a satellite to us.
Yeah, we have at IAST we have already developed and launched several satellites, about 6 of them. These are experimental satellites for students and other researchers with international collaboration as well as in-house development. So we developed that and launched that. Other colleges can also collaborate with us. Now ISRO provides 2 research platforms for testing technologies in space. One of that is called POEM. The other is actually called SMILE. So POEM is based on the 4th stage of PSLV rockets. SMILE is based on the 4th stage of the SSLV rocket. So these platforms, after launching the satellite, it will be orbiting the Earth for several years. And ISRO gives this orbiting 4th stage, which are going to be debris soon, for experiments for short durations, like a few months, for researchers like you and me. So that is actually a very good platform for testing, space-based robotic kind of applications.
And sir, how as in India can increase more amount of work, like the technology, the advancement what China is doing in various areas? Now, how we can go further ahead and compete with the China and increase our technology?
Yeah, it's a very good question. In fact, we have to study China more seriously than we have ever done. If you look at the ancient India-China relationship, there was no war that we know that happened before 1960s between India and China. And there were significant cultural exchanges. We gave them Kalari, and that became Confug there, and we gave them Buddhism, and that became the mainstream religion there. And they gave us so many things, including that of the China clay and China net and so on. So there were a lot of cultural exchanges, technology exchanges, market exchanges between India and China too. But of course, we recently had some incidents from 60 to maybe 2020. Now we are now reinventing ourselves between the relationship between India and China. As I have earlier mentioned, now our students are going to China for higher studies. Some of the Chinese university classrooms have 80% of students from India, and some postdocs and faculty visiting scientists are also going to be working in China too. So we have to study on this particular aspect that you have mentioned about how China is able to do such kind of volume manufacturing, and more importantly, how China is able to bring down the price to such a low extent that we cannot imagine, not even any of the Western
With the
countries can
latest
imagine.
technology.
With the latest technology. So it is in our universities, in our classrooms and laboratories, we need to train our students to to develop that kind of skill. So my observation is that they have reformed themselves to manufacturing, yeah, in the community itself. In Chawanlang's time, they have asked the community to develop manufacturing in their own backyards. That gave the entire community the kind of manufacturing skill set. So the more people in the society with the more skills, then innovation can simply grow out of that. So we need to train more students with the hands-on skills, train them to solve local problems and local products like this being another one product. So naturally the ability to develop faster and better products will come. That's very, very important.
That means you're telling that, where the problem is there, let us find the solution there. And also the training at the local itself.
Correct. Yes. That right now our academic institutions are actually not training students to be solving hands-on problems. So we have to have mandatory at least 1 dozen hackathons into our curriculum that students should be doing. Okay, that hands-on capability should come. Right now, students are earning CGPA and degree certificate, but the skill has to come only after joining a company. So that situation has to change quite a lot. So this is why I am encouraging many people to visit China and see how they work, how they actually building, how they take decisions in their universities and their systems, so they are able to really move faster. And it is high time that we have to practice, because when I looked at the 2017, okay, 2017 is like 50 years from now. Many of the undergraduate students we may become our age by then. India will have doubled the population of China. So we are going to see a situation that no other country has ever seen, and we cannot take a solution from any other country to handle the situation here. So we have to locally grow solutions and solve that, and that too in massive scale. So that means collectively as faculty members and researchers, we are going to face a very responsible situation.
Because, we should have a technical hubs at each and every villages and the district level to solve the issues.
In fact, every college should have a company that is selling products like this. Okay, one should be able to go to the college and purchase a product based on the technology developed in their labs. Now, the cost of having that kind of a company within a university or within a college is so high that nobody is able to do that. So, how to bring that? Now, if I'm walking into Amrita University, I should be able to purchase products developed from the labs at an affordable way. If I want to buy a, say, advanced wheelchair, I should be able to come to the nearest university and get that. So, that should be accessible to the general public.
So the production unit should also be there.
It should be there. Yes, correct. So as today morning, the Leon Bots company has mentioned right now they are all outsourcing the key subsystems. All these subsystems are coming from where? Vast majority of the subsystems are coming from China. In fact, about 70 to 80% of India's biomedical imports happen from China only. Okay, and if you look at the items, many of these things have a national capability within India, but still we do not have a ecosystem, a healthy, survivable ecosystem for people to actually, develop and sell internally. So that ecosystem has to come.
Thank you very much, sir.
Thank you, Dr. B.S. Manoj, sir, for the presentation. Now I invite Dr. Ananda Padmanabhan, Assistant Professor, Department of Electronics and Communication Engineering, to present Dr. B.S. Manoj with a token of appreciation.
Yeah, thank you.
Thank you to all our keynote speakers for their thought provoking and inspiring addresses. We are truly enriched by your insight. With that, we now break for lunch. We hope everyone takes this time to relax, reflect, and enjoy some delicious food. Lunch for faculty members, coordinators, and volunteers will be served at Annapurneshwari Hall. And for our keynote speakers and guests of honor, lunch will be served at Anugraha Hall. Our volunteers will be happy to guide you to the respective venues. We request everyone to kindly return and be seated by 2:30 p.m. as we resume the next round of keynote sessions. The paper presentation session will commence as per schedule from 2:30 p.m. onwards at the stipulated venues as communicated. Enjoy your meal and see you back soon for our engaging afternoon ahead.
now begin the final keynote sessions at this venue, a concluding highlight of today's inaugural program. To help our speakers manage their time, a general bell will be rung at the 25-minute mark. This will serve as a cue to begin wrapping up, with 5 minutes remaining to conclude the presentation. Our next keynote speaker is Mr. Balram Shankaran, Scientist G, Senior Grade, Technology Transfer at Biomedical Technology, Wing of Sri Chitradirunal Institute of Medical Sciences and Technology at Trivandrum. Mr. Balram Shankaran is an alumnus of College of Engineering Trivandrum and has been a research scholar at IIT Madras and Japanese government scholar at University of Tsukuba, Japan. He has received fellowship to visit Office of Technology Transfer, NIH, USA, and MHRA in UK. He has presented papers at WHO Global MedTech Forum, Geneva, and ISHQA, Seoul. He is also the founder CEO of TimeEd, a technology business incubator for incubating and supporting startups in medical technology domain at Sri Chitradirunal Institute. As CEO of TimeEd, he provides leadership to all activities to identify, select, mentor, nurture, and invest in startups and entrepreneurs pursuing medical device projects. We are honored to invite Mr. Balram Shankaran to deliver the keynote address.
Good afternoon, friends. I know you're all back after lunch, and probably there is a chance that you may go to sleep, and probably you may see some dreams also. So I'm just reminded of the quote by our former president, Abdul Kalam, what he said about dreams. Dream is not something what you see in your sleep. A dream is something which should not let you sleep. So with that, I thank the organizers for giving me this opportunity. So greetings from my institution, Chitradirunal Institute for Medical Sciences and Technology, which is an institution which attempts to bridge the gap between medical science and technology. Today we are living in an era where the boundaries between different disciplines are merging, and healthcare is no exception. And today when you go to a hospital, you wonder if the medical practitioners are really from life science domain, or they are half of engineers and technologists. So the driving force, the credo, the motto of all of us working in this institute is to give life to innovation and innovation to life, meaning we are engaged in the science and practice of innovations that have something to do with life. And more importantly, we see there are many innovations around us, but they remain at the laboratories, they remain at the prototype stage. But here we are committed to bringing or giving life to this innovation, meaning these innovations should finally reach the patients for whom it is designed. Today, like I said earlier, healthcare is full of gadgets, it's full of technology. There are hundreds and thousands of products which are being used today in healthcare. And what does it mean to youngsters like you who are pursuing a career in engineering? It means there is a lot of opportunity for you to contribute and to make new and new innovations better gadgets, equipments that are useful for all of us, for humanity at large. Why? Because in spite of all this progress that we have made today, we know that there are a lot of things lacking in healthcare. Even though we have progressed so much in all spheres of technologies, still we don't have the best of treatment available. There is a big mismatch gap in the 4 A's of healthcare. The 4 A's being availability, affordability, appropriateness, and accessibility. So if you look at any of these 4 parameters, there are a lot of things lacking, there are a lot of lacunae, and there is a great opportunity for people, especially youngsters, full of enthusiasm, energy, to solve problems, to solve what we call unmet clinical needs. There is a huge opportunity out there. And that is what I'm trying to convey through this short presentation. If you go to a hospital, I hope you don't need to go, but if at any time you visit a hospital, you will see, starting from the stethoscope, which the doctor uses, to the wheelchair, to the X-ray, to the CT scan, to the bandages, to the blood bags, to the syringes. Everything is a product of engineers or technology. All the things that you see in a hospital, other than the medicine or the vaccines, has all a technology component. That means there's a huge set of products, what we call medical devices. The problem is, in our country, most of these devices are being imported. And that is probably one of the reasons why these are very expensive and why medical cost is very, very high, unaffordable. Again, it brings back the point that we are not making enough of this in our country. And that is because of this gap between engineers and medicine in our country. And here is a great opportunity to bridge this gap. Since this is a conference on robotics, mechatronics, and I'm sure the people you sitting on the other side are better knowledgeable about this area. Just broadly speaking, robotics is something which is again playing a crucial role in healthcare and has got a great potential going forward. You heard the earlier speakers in the morning also touching upon this topic. And there are several ways in which robots are taking over healthcare in different areas like surgeries. Robots, we know, are now performing surgeries with better precision, better accuracy, better patient outcomes, faster recoveries, but at a higher cost. And there are robots which are able to deliver drugs precisely at different organs of interest. They are able to access with what we call minimal invasiveness. And then we have other robots in the what we call as external, or which help or assist patients who are disabled or who have movement impairment, to maybe walk, to move around. And there are other robots which help patients who need exercises, physiotherapies, recoveries from diseases like strokes. So robots are playing the role of physiotherapist to do these repetitive exercises which are otherwise boring. And then there are other robotic prostheses which are replacement for some damaged parts. So there is a lot of areas in which robots are contributing in healthcare. But I was particularly impressed with this role that robots is playing today. They are playing the role of a caregiver. Looking at this, I sometimes feel whether human beings are becoming more machine-like and whether robots are becoming more human and humane. So today, humans are depending more and more on robots for social, for fulfilling their social needs, for companionship, and as a caregiver. And this is going to become a reality going forward. And there are a lot of companies, if you look at this, most of these are companies outside India, all multinationals. They are coming up with a lot of solutions. It's a very big market out there for medical robots. Billions of dollars of opportunity. But what we import is not something which is appropriate, which is not affordable, which is not accessible for our people. So there is a need for indigenous development of these. Given the strong technical and software power of the country, there's no reason why we should not be able to develop our own solutions. And when you develop robots, it has to be something which is designed for our culture, for our people. They should be able to communicate in our language. They should be communicate and identify with our cultural behaviors. So it's very difficult for us to use an imported robot. And so that is where we need our own indigenous capabilities in these areas. Now, why I'm here is because I had this privilege and opportunity to create an organization called TIMED at my institute, which is basically a platform, for anybody, young or old, new or experienced person, who has some innovative ideas to develop a medical product, a medical device. If somebody has that kind of an idea, TIMED provides a good, nurturing, supporting platform for him to take forward his ideas and implement it. That is what I was talking about, dreams. If you have a dream, if you have a passion, over and above that, if you have the skills and if you have the capability to solve a problem in an innovative way, something which is going to come out with affordable and appropriate solutions for the healthcare needs of our people, then we have a facility where we can support you. So you come with a seed of an idea, and we help you have strong roots, and you can have fruits of that, which is going to be beneficial for not only yourself, but also the society. And we have, this is the pictures of the physical infrastructure that we have set up in our institute. And we have several startups, people fresh out of college or people who have been experienced, worked in industry, and they all come and take our support. And just to inspire you, we also have some success stories, like products coming out of our startups, which are actually being used by the people. There are several of them. They are working in like early detection of diseases like probably cancer. One of them is an oral cancer tool, which is a very portable handheld device, which takes the pain of patients going to the hospital and going through painful procedures. So it's a very easy to use device. This is a team which was just out of college, and then they came up with some ideas to solve some of the very common problems, like infusions, which happens maybe thousands of infusions happening every minute, but that's a pain point for every nurse, every bystander. So they try to take that pain by building some small gadgets. And with one product, they have expanded, and they're doing well. They have raised investments, they are raised revenues, and going very well. This is something which is very relevant to this audience, because this is something which has come out from a very nearby place. This is Sonia, who was an engineering graduate. She is from Kollam, a small Kollam, a tier 3 city in the country, and a working mother, and she has developed this very small device, which is very, there is no weight, very lightweight, there are no wires, but it is able to perform a very important function of measuring and recording your ECGs continuously for over 10 days. It's a wearable device. You know, when you want to take ECG, there are a lot of wires, and it's a very messy, cumbersome process, but this is a very simple device, and it is able to take your ECG, send it to the cloud, process it using AI, and give very useful information to the clinicians. It's a very life-saving device, and we can all be proud that it has come from a very humble background. And there are a lot of people like dentists. They have come up with devices to solve the problems that they face in their practice daily. Then there are other products like wound care. So these are some of the products. This is a dentist. She was a practicing dentist. Then she found out a problem of lack of saliva in certain people, elderly people who cannot swallow medicines or swallow food because there is no saliva in their mouth. So she came with the idea of oral rehydration patch. This is a young boy from Gujarat who came up with a design to develop some instruments for laparoscopic surgeries. The innovation here is that earlier you would require two instruments, one for cutting a tissue and another one for sealing the tissue. But he is a mechanical engineer, so he combined both these functions into a single instrument where it can do both cutting and sealing, and it's very useful for laparoscopic surgeons. So this is one of the teams. They did their MTech from the College of Engineering, Trivandrum. And one of the students, he himself had a road accident. So he had to, one of his sides was paralyzed for some time, and he had to do a lot of physiotherapy to recover his health. So that motivated him to take up this challenge of creating an exoskeleton for upper limb exercise. And he got a funding of 50 lakhs from the Department of Biotechnology. And then these two students, they came up with a device which is one of the world's, or what we can call at par with any world class exoskeleton. And they have done it with a very meager funding of 50 lakhs. And people cannot believe that they were able to do it with such a low investment. And most of the things they have done themselves, including the operating system, everything. They have not relied on outside vendors. They have done it in-house. So that is what, when you have talent, you have motivation, you can really do unbelievable things. Some of these startups that we have supported, and we have certain funding schemes also, like the Nidhi Prayas of the Department of Science and Technology, which is basically a grant for somebody who is just an idea to build prototypes. And we have certain facilities like Tinker Labs. And we also have support people in patenting and all that other support that somebody needs. So this is what I wanted to convey very briefly. The idea being to share that there is an opportunity for you, those who are interested, especially in robotics. There is an opportunity, great opportunity in medical robotics or robots in healthcare. And if you have some idea sometime today, tomorrow, or later on, you can always come and discuss with us, because in our institute, we have this, not only this incubator, which will give you a physical support, we also have faculty. We also have an ICRM center for validation of exoskeletons. And we have clinicians who will be able to mentor and guide you in taking those ideas forwards. Yeah, so with that, I conclude. Thank you. Thank you.
Thank you, Mr. Balram Shankaran, for the presentation. Audience, any questions from your side?
Sir, actually, I have one of student who has come with a proposal of artificial pancreas, but we don't know where to start and how can we move forward. That was proposal actually he has brought around 6 months back. We tried with some things, but we thought that it is not going to be feasible for us to work on this. So anything from you which you can share so that we can process this forward?
It's a very tough problem. I remember we had some scientist who spent her lifetime, probably 20 years, and she retired without being finally able to put it in the clinic.
Okay.
So some of these are very challenging problems to address, and without knowing more or without knowing what he has proposed, it's not fair on my part to comment on it. But generally, what I've seen is there are big problems, and people try to simplify that and come up with solutions which may not really, they may be good like an academic project, like a student project. It may help them get some skills, it may help them get some training. But if you think that that is something going to solve a problem, it is very difficult unless there is some breakthrough in that. Because it's a very challenging thing.
Yeah, actually.
But if we know what it is, then we can really comment in and do justice to that.
We have discussed the same thing with 2 doctors also, but we couldn't get any help.
Again, when it's a general guidance, when you talk to doctors, many people say we have talked to doctors. We have to talk to the right doctor. One, specialization, he should be the right person. Second, he should have an understanding. So he may be a good clinician, but he may not have a research and understanding. So it's very important. It's like choosing the right mentor for a project.
Okay, thank you, sir.
Anybody else?
Now we invite Brahmacharya Dr. Rimra, Chairperson, Department of Electronics and Communication Engineering, to present Mr. Balram Shankaran with a token of appreciation.
Our keynote speaker for this next session is Dr. Arun P., Head of the Department of Electronics and Communication Engineering at St. Joseph's College of Engineering and Technology, Palai. Dr. Arun P. is an Associate Professor and Head of the Department of Electronics and Communication Engineering at St. Joseph's College of Engineering and Technology, Palai. With over 19 years of teaching and research experience, he specializes in machine learning applications in healthcare and signal processing. A senior member of IEEE, he currently serves as the chair of IEEE RAS Kerala chapter and has previously held roles as secretary, IEEE RAS Kerala chapter, and branch counselor of IEEE SP SJCET. He has coordinated multiple AICTE funded FTPs and IEEE initiatives, published extensively, and guided numerous research and academic activities. We are honored to invite Dr. Arun P. to deliver the keynote address.
Good afternoon, ladies and gentlemen. As the narrator was spoken out, myself, Dr. Arun P. I am standing before you as a representative of IEEE Robotics and Automation Society Kerala chapter. And also I am serving with St. Joseph's College of Engineering and Technology in the Department of Electronics and Communication Engineering. A very good afternoon to one and all. First of all, I would like to thank to the entire Amrita family for giving me with this opportunity to talk before you on the topic. My topic for today's presentation is intelligent mechatronic systems for biomedical rehabilitation, bridging electronics and human recovery. I told you now, I am from IEEE family. The tagline of IEEE is advancing technology for humanity. In line with that, I have chosen a topic which comprises both the technology part and how, as we all are engineers, how can we serve our community without compromising ethics and other kind of standards. So I'm sure that most of the audiences are student community. So I believe this particular session will give you with some kind of inputs so that once you get into another field of era, you will definitely inculcate the technology to that community in a professional and a better way without compromising ethical standards. Yeah, sorry. And this is a content for my presentation. Sorry for the trouble in between. Okay, and this is a content I would like to convey you in a brief manner. And why rehabilitation technology is required in nowadays. From the slide itself, we can see that the demanding of rehabilitation in nowadays is highly increasing day by day. That itself, the statistics saying, you can see there from the WHO report taken in 2024, we can see that the global stroke impact is 15 million. That is really alarming. And then come to the aging population. As per the UN World Population Prospectus, 1 in 6 people is greater than 65 years by 2050. And another statistics, the rehabilitation gap, that in the sense, nowadays only 30% of the needy pupils are getting the support from that rehabilitation assistance in many ways, especially in biomedical related support, as Balram sir was pointed out little bit earlier. And similarly, the funding requirement as per
another McKinsey Health statistics, it is around US dollar 2.5 trillion per year. And this simple slide explain you the concept of the evolution of mechatronics, right from that mechanical systems to the human generated AI system, where we are currently working with main emphasis focusing on that advanced kind of processors and then machine learning platforms, artificial intelligence, etc., etc. And this is an interesting slide. We all are love our nature. This particular slide showcase you two kind of inspiration. One is a nature inspired thing which lead to the sensor array design, and the bottom one is nothing but a lizard inspired development of a prosthetic arm, and from there a human machine interface is also shown over. So that itself says that whatever be the technology, we are not gone away from that nature. We truly in line with the systems supported or provided by the nature, and based on that only we are moving with so many kind of advanced research and developments in technological era for the social benefit of the community. And this is a basic anatomy of a basic intelligent system, how it we looking like. It comprises around 6 blocks. The first one is nothing but sensors. The students might be knowing how that data are being taken by different kind of sensors in robotics, specifically in the area of rehabilitation. We have to mainly taken up two kind of sensor input. One is neuromuscular data and another one is kinematic data. One is related with biological information. There we might have to use different kind of sensors like EMG sensor, EEG sensors, etc., etc. And then for controlling the movement related information, we have that kinematic data. For that, a kind of sensors are also available. And that kind of information are to be fed into another unit, which is signal processing. In that signal processing part, there is so many scenarios are there. We'll have to compromise certain kind of parameters there. In addition to that, some of the noises or artifacts has to be removed. Sophisticated algorithms are there. And from there, that information has to be given to a powerful controller. Controller itself doing so many kind of decision making inside. So many controllers are available while doing that student project, and you might have familiarized with so-called development boards like Arduino Uno and then Raspberry Pi, etc., etc. At the high-end side, we have high-end GPUs, TPUs, etc., supported by Google, NVIDIA, and leading giants, etc. And from there, based on the decisions, we'll have to control that activators properly. Activators in the sense, if something happened to my right upper limb, we have to take some kind of actions based on the signal being processed, and it has been taken up by that particular sensor. So that kind of actionable items have been designed, and that delay mechanism has to be given back to the controller by taking that sensors and it's proper coordinated. And that is what is done in that actuator side. And then the next level is AI. AI level will have to process a huge kind of information. So real-time data has to be processed. During that time, definitely we'll have to take the facilities and advantages of that AI module. And then obviously, this all parameters are required for the support of a patient. A kind of closed feedback system has definitely been evolved there to control and coordinate all the parameters suitably. And this is a fundamental block. In each and every block, as students, you should have plenty of opportunities, both in funding side as well as in research side, etc. Each and every block will give you that much expertise when you are stepping up to another level during your career in engineering. And these are again one of the slide which related to the previous one I have presented before you, key enabling technologies. I have categorized the this into 4 sessions, starting from advanced sensing mechanism. I told you, there are many cases are there. We'll have to sometimes focus on EEG, EMG. They belong to neuro, electro kind of biological information. And for that, different kind of sensors are available. And then for processing kinematic kind of information or movement kind of data procurement, we have that initial kind of sensors are there. And then the controller side, the embedded system is very powerful in nowadays. And to protect that data and to control that mechanism, so many embedded powerful processors and controllers are nowadays available, including GPUs. And virtual platforms are also there to support you with that kind of real-time machine data protection and processing, etc. At the right side, we can see that actuation and human-machine interfaces. And my talk is mainly focusing on that rehabilitation, specifically related to human body, maybe Parkinson kind of disease detection, and paralyzed case in another amputation, and that kind of cases, the robots which are shown in that particular part, like exoskeletons, and then compliant robotics and prosthetics arms, etc., having that much significance in nowadays. And this is a kind of research landscape, and students and the participants who are very much interested in this particular area, 9 areas I have identified everywhere, and you have plenty of opportunities are ahead. And which is your interesting area, please sort it out and then do work on their area and try to progress with that. And my talk is mainly focusing on the cluster B, which I have shown in the previous slide. And here you can see that rehabilitation robotics and assistive device. It comprises basically 4 major part. The left one is nothing but I have already communicated you, that is sensing, taking up the data and processing the signals by using that electronics. And again, a control mechanism at the left side. And in the middle, there is a patient, a prosthetic arm and a prosthetic leg is there at the right side, and he is responding based on the input which is available in that feedback mechanism. In addition to that, from the left top, starting from the exoskeleton, a closed loop path is provided, and you can even see that kind of applications with the help of this particular image. And at the top, again, you can see that there is a sensing part, start from the sensing to control mechanism, and then based on the decision made by the controllers and all, we'll have to actuate it properly. And then the signal level and all other scenario has to be adapted by the patient who is under processing that particular prosthetic arm and leg. And then based on the input and feedback loop we have been receiving, we'll have to process it again, and the patient or the patient is being recovered. And this is basically the core of any kind of rehabilitation system. It comprises a 3-block layered structure. The first one is sensing and perception. Sensing and perception is again many sensors, very good sensors are nowadays available, including analog and digital sensors. Consider the case of EMG data. You might have heard that term, electromyograph. The muscle data has to be captured. For that, plenty of sensor modules are available. And one of the very cheap cost available sensor module for student related project development is nothing but SEN 240. Is a very, very good SCMG module capable enough to get the data in a very effective manner. And the internal structure of that SEN 240 is nothing but which simply comprises a differential amplifier. And that differential amplifier will take that muscle data changes and process it, and that analog data has to be given to a suitable controller platform. If more data has to be transferred, along with the single board computer like a Raspberry Pi or Arduino Uno, etc., that you are familiar with. And if more data are available, we'll have to take the benefit of that edge processors like Google or NVIDIA, Jetson, Xavier board, etc. While talking about that Jetson board, and for you students, my dear students, and there is a plenty of opportunities are available in NVIDIA platform for doing your kind of hobby projects, especially in that machine learning scenario and deep learning scenario. And in addition to that, plenty of free level courses are there. Moreover, that NVIDIA is supporting you with funding mechanisms and funding opportunities for assisting you to better your skill sets in that electronics and machine learning related area. And at the right side, the layer is nothing but intelligence layer. This specifically comprises of that a huge amount of data capability processing with the help of that machine learning strategy and a cloud platform. And so basically, this is a core mechatronic system. And in this, the mechatronic core will do all the actuation process with respect to the robot related control and coordination mechanism. And this is again come to that quality of the closed loop data. In rehabilitation, this is not a single kind of conversation. This is a co-adaptation process happening between man and machine. Simply saying this is not a radio. That is a, in my word, I can say that this is something like a high bandwidth, high speed mobile network communication. So now both cases, human has to interact with machines. Similarly, the information from the machine has to be given back to the human for its input taking and to update in that way. So that quality of the control feedback loop is nothing but every time it monitor the performance of the sensor data as well as it evaluate the rehabilitation parameters of the human which is under consideration. And a brief view of the feedback loop in rehabilitation process is shown at the right side of the screen. The next one is very vital in the case of electronic product design. Many of the case students, when you are progressing with your product development, your focus is mainly only on the intelligent part related system, like the advanced sensors, selection of intelligent processor, machine learning platform, etc. Your ultimate aim is to develop a very good prototype, fully functional in nature, without compromising ethical standard and another communication standard, etc. But this case, many a time, as a teacher, I can say that many of the cases, the prototype of the students will work for at least for 2 minutes. And after that, they will coming to say and saying that, sir, teacher, this is not working nowadays. Or half an hour before, this was worked in a fully better way. Now it is not working. The thing is that your power supply design was some kind of mismatching. You are not properly designed your power supply in that way. So the participants, please do focus on power supply design, whatever be the hardware platform. Estimate the total power consumption. From there, we'll have to reverse engineer, and from that part, you design your power supply in a better way. Here, you can see that the battery pack, and for your clarity purpose, I have taken up here a 12 to 20 watt lithium ion battery, and from there, derivation of different kind of power supplies are shown in the screen, and there is a power management unit, which indeed comprises of many kind of compressors, converters, DC to DC converter in the sense, in sometimes you'll have to step up that power requirement to another extremity, and sometimes you'll have to slow down that voltage level to another level, and then this kind of robotic related mechatronic system comprises motors mainly, and then sudden kind of surges or spike will be there, so that protection purpose a kind of super capacitors are employed. And then safety is one of the main thing when we have to interact with that human body. So battery management system has to be incorporated there. So in my word, I can say that that power supply is nothing but which is the heart of any electronic system. And if the power supply design was failed, whatever be the things that you have done is waste. So when you design a very good project or whatever be hardware or software related product, please keep in mind that the power supply design is very vital. And the current voltage parameter and power consumption, etc., has to be considered in your mind. And these are some of the work associated with me. And the first one is nothing but nowadays Parkinson is one of the major neurodivergent problem. And this work demonstrates you this is a machine learning strategy by employing decision trees to detect the presence of Parkinson by analyzing the acoustic data. Acoustic data in the sense the vowels A, E, I, O, and U. In this case, we have sensed that acoustic data, specifically A and I vowels here, and that vowels are being recorded by using microphones, and they have fed into a system, and from there a kind of signal processing part have been done by us, and we have evaluated the performance of that particular signal by using some kind of statistical model like statistical analysis, case test, box whistle plot, range, median value, etc. And later we identified that of this the better vowel parameters are A and I. And this is a software side only, I told you, no. And now the rest of the future work is nothing but from there we'll have to reposition this to another hardware structure. Now the software part is ready. We'll have to integrate it into a powerful processor or into a normal SBC kind of computer for prediction. If the data is very huge, obviously a kind of cloud platform is required. To cope up with real-time application, more data has to be processed, then the cloud platform is required. And based on the performance and the evaluation speed, maybe we might have to incorporate GPUs into that. And this is the work which we have published in one of the book. The next is another use case. Nowadays, everybody is interested to maintain their health. In the initial part of my session, I have conveyed you that SEMG, surface electromyography, and we have sensed that SEMG data by using that so-called SEMG sensor SEN 240. And that sensed data have been given to Raspberry Pi based board. And in another case, we have tested it with ESP32. We processed it and successfully we have segregated type 1 and type 2 muscle fibers, low twist and high twist muscle fibers. And in this, we have inspected many features on the subjects we have examined. For this particular paper, we have taken up that data from a publicly available data set. In another case, we have, I told you now that we have devised a kind of non-invasive data acquisition system. By using that system, we have got the design patent for that. And all this is done by my own students. The students who are pursuing their BTech in 6th semester and now they are in the 7th semester. So for my dear students, plenty of opportunities are there for you to excel your technical skill. So more information of this is required. I can help you out in this area. And this is the integration of both. What is the future scope is this? One paper was related with that acoustic kind of data processing, and the another one was related with a non-invasive kind of data acquisition by using an electrode placement, specifically in the form of SEMG. The rest of the part is we'll have to port that particular data into a processor for prediction. That can be again given into a prosthetic arm or any kind of impairment has been happened. There we have that possibility. And these are come under the future prospects of these two research works. And I told you, this is something like human-machine co-adaptation. Both kind of interactions are required, not from the left side. Simultaneously, in certain cases, we'll have to work together. Human has to listen or learn something from the machines in a certain case. And in another context, that robot or the machine has to take or to learn something from the human. That is what it is, not a radio. It is a kind of high-speed mobile communication. And now, coming into the IEEE, I am representing IEEE Robotics and Automation Society. And here you can see that plenty of opportunities are there for students. Technical committees are there, and that website is there. I will share you the link to that website. Now I'm unable to showcase it by hyperlink, and you can see many options are shown there over. The parent site is shown under the bottom, IEEE-RIS.org. Dear students, if you are not IEEE member, try to take the fruitfulness of IEEE. Do volunteer there. You should get plenty of opportunities there, including travel support for attending conferences. Plenty of grants are being provided by IEEE. And then at the right side, you can see that a couple of flagship publications from the IEEE, like IEEE Transactions on Robotics, then IEEE Robotics and Automation Letter, IEEE Transactions on Medical Robotics and Bionics, etc. And in the IEEE parent side, at the right top bottom, you can see that latest news. So in that portion, at present a call for is open for you, ideal travel support for students. The participants who are coming here for presentation, you can also participate there. Those who are unable to publish or provide any kind of related matter in the technical area can apply for this. Please get into that link. It is currently active now. Please take this opportunity. I think more than 30,000 Indian rupees are available for that particular contest, I think. And similarly, we, the IEEE Robotics and Automation Society Kerala chapter, under the fraternity of IEEE Kerala session, also having plenty of options for the budding engineers in that mechatronics area, and that is provided in that particular part at the right side. You can also go through that. At the end of my presentation, I have provided here with that link. If anybody require, you can take a screenshot of that. And then the last one, RIS student website. In that, so many tutorials, how to upskill your technical knowledge in the platform of robotics and automation, electronics and communication, biomedical engineering, etc., are listed there. In addition to that, certain kind of courses which is freely available for students. Any student, even though you are not an IEEE member, students can do register there, and you can even get the flexibility of getting the choice of that IEEE courses there. And this is a last part of my presentation. When electronics learn from human and human read through machines, really that rehabilitation becomes meaningful. And with this, let me conclude. These are the references which I have gone through. And this is what the link I have told you before in the presentation. If anybody wanted to take the screenshot, you can have it now. That's it. Any query from your side? I can answer, please. Pardon? And for flagship data repository, sir. Yeah. And we have also devised a product by using, we have gathered it up. And for that, we have got the patent too. Now, for that particular work, we have tried only the decision tree. In any other cases, we have tried that SVM, and then Canon also tried.
Anybody else? Okay, thank you, Dr. Arun P, for that presentation. And now we invite Dr. Usha Devi Amma, Professor, Department of Electronics and Communication Engineering, to present Dr. Arun P with a token of appreciation.
With this, all events at this venue have officially concluded. We now invite all attendees to proceed to the respective venues for the parallel sessions and programs scheduled for the afternoon. Please refer to the conference schedule or contact our volunteers for guidance on session locations. We wish you a productive and engaging afternoon ahead. Thank you all once again. Namaskar.